turning on watching the VOD because there's nobody here at the moment. So yeah, YouTube's just detected that I'm live. That's good. OBS is showing something. Okay, so today I'm going to be working on making like a really basic Tetris that will run on a Raspberry Pi Pico that I've got on my desk, which is going to be fun for streaming without a camera because you won't be able to see what's happening. At the moment, I've just got a very basic, someone posted in the Discord like a setup that they had for running it on a Pico, and I basically just copied that, modified it slightly to be 50% more power efficient by simply making it actually use Embassy's sleep rather than what the ticker weight. Rather than what they were doing, which was putting the thread to sleep, because putting the thread to sleep apparently still consumes a lot of power. Because I think it's just that Embassy doesn't detect that it can go into like a lower energy mode. One thing I need to do is probably turn the clock cycles down, because I'm going to be using e-paper, which is horrendously slow refresh rate, which means that I really do not need the CPU to be running fast. So if I can turn the CPU speed like right down in order to be able to just get better power consumption, that would be best, because the project I have in mind is stupidly needs to be stupidly efficient. Like it at the moment, I think the Pico just running on its own is using let's say it is using 22 milliamps at 5 volts. So it's using 100 microwatts or 100 milliwatts, and all it's doing is blinking an LED. So if we can get that down, that'd be nice. So I am curious if I'm able to do anything. I don't know how to even attempt to do this stuff. Oh, we can't use P until we've got P. Yeah, this init config. Maybe that's probably the wrong look. So I want to go like that config equal embassy RP config. No, yeah, it's init, and then it's calling config. There is config. Then we say clocks, and then embassy RP config. Clocks. I'm assuming that's what you want. You want a clocks config. There it is. So we go here. And there we go. Okay, so you're missing a whole bunch of information, and then we like default the rest of you because I don't care at the moment. I did like actually look into this stuff to see what's in here. So first off, the only thing we can configure is the clocks, which is fun. So if you don't know what RSO is, so a bunch of acronyms that I don't remember. I've done some Pico development before, but I do not remember this stuff very well. Mostly because it's a lot of acronyms that people then go, yeah, I can't use those acronyms anymore. So these two are optionals. So I actually want to go in here and like look what the defaults are. What are the actual like clock configuration design for external crystal? Okay, don't care. Okay, for internal oscillator, so RSOC. Okay, so divide strength. Okay, 2040. RTC clock. Okay. ADC clock, system clock. So this is, I'm assuming, the clock, like when it does it. Rising edge, no, right and higher. Okay. Too high should not be used. Okay. Frequency range low. You've got a number in you, which is apparently FA4, medium A7, A5. So they're only different by 1 bit, which means I don't know. On-chip range oscillator configuration. Final frequency after the divider has been applied. Oscillator has a normal frequency of at medium range with divider 16 and all dividers strength set to 0. Other values should be STU. So okay. divisor strength for oscillator. Output divider. On chip ring oscillator configuration. So they have examples. I should probably go to the embassy website and look, or their GitHub. Funnily enough, every time I go to GitHub, it's the default one it goes to because I went here so often when I was trying to develop this shit previously. Before Bevy was compatible, and I found embassy really, really hard to use because I'd like keep static references to things and be like, well, I know I'm not going to be using it mutably twice because everything was like ref cells and stuff like that. Just to get around the borrow checker, whereas Bevy lets me like stick a resource in that holds the bus, and then I can just like pull the resource out when I need it, and I lose all the async stuff, but to be honest, most of the stuff I was doing did not need to be async. Anyway, go doing examples, and then RP, and go like, please tell me you have one that's like clock. Probably not. Clock. Overclock. Well, I want to do the opposite of overclock, but you know, system frequency. Okay, set up for clock frequency of 20 megahertz, setting all necessary defaults. Okay, so we want to go config. Ow, bit my fucking tongue. So apparently we got config new, and then we have the clock config. System. Well, that didn't work. They're using a function called system frequency. Where are they pulling system frequency from? What is it? Is it okay? Embassy RP clock config. They've also got something called clock underscore system frequency, but that's just a single thing, and then core voltage. Well, I don't have a core voltage, so that tells me I'm probably on the wrong. Nope, spelling it right would probably also help. Voltage. Yeah, so I must be on the wrong embassy build for the feature that they're showing off. That, or I don't have the feature enabled. That's definitely possible. CPU frequency for verification. Okay. Show core voltage for verification. Can I adjust the core voltage? Is that something that's actually configurable? That's kind of... Now, how are you getting this? Where are you getting this from? What version? How do I do this? Because if I can turn the core voltage down, that would probably also reduce power consumption, I would assume. So embassy time, embassy RP. Time driver, critical section import, RP2040, unstable pack, okay. Are you using a specific feature maybe? To go to TOML, and go RP, which is unstable time, critical section, nope. So that just means it's just they're just RP version 4. Maybe I should see if I can bump all these versions. No, they're on RP version 4. So where the hell are they pulling that from? Everything's 4. Apparently this should be 7. Kind of makes sense. But... oh, now it's yelling at me that it's not 7.0. Weird. What else is out of date? Rand, okay, don't care. I'm not using a lot of the stuff. This is just stuff that came with the thing that I was using. So if I want to say like cargo update. Well, I don't think anything really changed. I didn't see anything change. So I don't know where they're pulling that function from. Because they're just pulling in core voltage. What is it called? It's overclock. I do want to know the core voltage. It's in RP system core voltage. Okay. So if we go to embassy RP, wherever that's hiding, and then go to clock. I don't have a folder for clocks, okay, clocks. Core. Okay. So it turns up a whole bunch of times. But it's definitely a thing. Because I want to go the other way. I want to scale the voltage down. I think they're scaling the voltage up. Yeah, but where the hell are you calling that from? Like, I don't think there's a function just called core voltage. Oh no, there is. Okay, but why don't I have a function called core voltage? Because it's not behind a feature. What the hell? So they reckon it's on like line 1400. Or the file stops very short at 1400. RP0, well, this must be RP like main then? That's weird because the diff. Okay. I'm extra confused because like I'm in main, but what the fuck? Do I have to specify like a version somewhere? Weird. I don't want it to go to the GitHub stuff. Okay. Oh, that's gonna be fun. So we're gonna say git equal, and then we go. Do I just go to embassy? I don't remember how this git path works. And then copy this and be like, just go here, please. And I just copy. My brain always defaults to Control C first. So if I click copy something, all right, and then we go update. Is it gonna actually pull in to new version? It did. It doesn't like failed to select a version, embassy time driver required by package embassy. We satisfied demand version that meets the requirement to wait, where are you? Embassy time, I thought I had 4. I do have 4. Okay. Wait, what? No, my multimeter doesn't like that. I'm not touching it. Okay, the packaging review time driver links to embassy time as well. Okay, so this is going to become really obnoxious really quick, isn't it? And I'm going to have to go say, how do I patch? Patch. Yeah. Patch dot crates.io. Can I get the AI to do this and be like, oh, it's a hash. Patch. Patch all crates starting with embassy to use git version. I don't think that's correct. I like that you think there's some kind of thing that needs correcting there. Okay, you can correct that. Does that work? Can I go update now? No. I don't think I can say embassy wildcard. Yeah. Embassy dash wildcard? No. Expanded identifier. It would help if I actually knew how to do patching in Rust. Okay, so how to patch cargo. No, wait. traits. Override dependency. Something dependencies, patch, so we just do that, but it's just saying I don't know, it's like embassy time. It's right, which is annoying because damn. Alright, then we can get rid of this bit and make the whole thing just that little bit neater for anyone that doesn't want to use the we should probably patch embassy futures. Why did you not patch embassy futures? No. Okay. Well, Cortex doesn't get patched, you idiot. This is embedded embassy. Okay, so that seems to be everything. So we can cargo update and go, are you going to actually work? Sure, you seem to have worked. So if I run this, does core voltage work now? Cool. So that implies that I can set the core voltage. So what we want to do is we want to say we should now have that frequency, system frequency, and then we want to say that the system frequency, we want something like maybe 30 megahertz, which is going to be real slow for Pico. And then we pass in config. Yes, got you. Okay. So what I want to do is configure clock drivers for wait, what? Okay, when using a 12 Hz crystal, you have to set PLA. Okay, wait. Clock configuration to achieve this requested system frequency using the usual on an error is not a valid parameter, could not be found. Note on core voltage for RP-2040, the data that only should augment core voltage up to 13 megahertz. Okay, default. Above 30 megahertz is 1.15, but the core content in the text of the data sheet that way all other frequencies below and above not documented, not covered here. In case you want to go below or above and want a different voltage, you have to set manually and with caution. Okay, a point in time there is no official manufacturer chip. The clock figure. Okay, so is this actually going to work? Is the question. Why is it complaining? What have I done wrong? Expected a semicolon. Wait, what? There's a semicolon there. What do you mean? Okay. New clock config system frequency. What is your problem? You're a result. So we just say we got unwrap. Oh no, we need to go the other way. We have to use the other unwrap so that it actually gives us an error message. Otherwise, the whole thing will just crash and then it won't tell me anything because it crashed. If you use this unwrap, because it'll print the error back to me. Why aren't you still complaining? Okay, so expect struct config found result clock config clock error. Argument to this function are incorrect. No. Okay, but I did call unwrap on you. Okay, you just didn't. Okay, I think there's something weird going on with using the Rust analyzer in a non-native format. Let's see what my multimeter says. So at the moment we're drawing 22 milliwatts, or milliamps, which is 100 milliwatts because 5 volts. I assume it's 5 volts. It's my PC supply. And it's blinking an LED, so the milliwatts is bouncing. It's not like any of you can see it. But yeah, just for the sake of anyone following along. So let's see what happens. I'm curious if it'll actually work because I think dropping it down to 30,000 might be a bit too slow, and I've been told there's a certain speed you can't go below in it before it stops working altogether. The hope is that the 30 milliwatts, it's 30,000 will still run fine, and then just draw less power. Okay, well, it's running fine, and it's drawing well, 10 when it's not blinking, when the lid's not on, and 12 when the lid's on. So it's not even 12, it's 11. It's bouncing between 11 and 12. So interesting. Can we go slower? I don't know. I'm curious. I'm curious. I also want to know what happens if I like tell it to wait for me to press a button and don't do anything, but I don't know how to actually make everything go to sleep. So there's a should get rid of a lot of this stuff because I'm not going to use it ever, because I don't want multiple cores running, because again we're really trying to cut down on the like power consumption so that I can. Okay, so I'm curious if I can drop the voltage because I'm switching so slowly. So can I say like config dot, so apparently not. Clocks, of course there's only one, clocks dot system voltage stabilization delay. System clock dot, right. Where was it setting the voltage? I saw that in here. I was digging through the examples. And then we go, wait, is this the right example? Yes, it is. So we want to go to overclock and go, where the hell? So I use core voltage, and calling core voltage does what exactly? Oh look, I can drop the voltage right down to like 0.8. Well, that's good to know. Oh, it goes even lower apparently, but that's on the 2030, 2350, which I don't have. I got 2040. So chip reset. Pack vreg and chip reset. Okay. vreg read VSL output voltage select. So I'm assuming the default, so default's 1.1. Can I drop it down to like 1? I want to go as low as I can go and see if it still works, and then we will work from there. If we need to increase it, we'll increase. Where exactly do when I set that though? Where is that passed in to the config? Go back here, go clock config. Where the hell is core voltage? Oh, it's just literally called core voltage. Okay, so we just said like core voltage equals embassy RP clocks core voltage V 0.8. We didn't make you mutable, so. And then we go, is this going to save me a lot of power, or is this just going to do nothing? We'll find out. So, again, the goal is to be 10, because that drops us down to only needing 50 milliwatts. Which is still depressingly high for what I want to do. Especially considering we're not even driving the screen or anything at the moment. We're just blinking LED. So, curiosities. Hello. I'm terrible with names. Elma Hurry? Okay, I'm butchering anything. Okay. Oh, it's running. It's blinking. It's now using 7.5. So that's beyond my mental math skills at the moment. So we're going to go here. I'm going to 7 times 5, 35 milliwatts. Or milliamps. Milliwatts was correct. Never mind. It's using 7 amps. Yeah. I also just can't read half the time, so I don't like reading people's names because it's one of those. It's a guess at how it's pronounced, and my reading is so fucking atrocious that don't want to offend people by getting their names wrong. Okay, so what's happening at the moment, brain? So we got 7.5 volts. It's about. Okay, that's cool. That's cool. So. Interesting. What do I have that calculator? So it's 7.5 times 5 gives us 37 milliwatts. Okay. Again, we're still not doing anything with this power, but can we go slower? What? Let's Google. Because I've been told that there is a minimum speed, but I don't know if that was actually a minimum speed with the Raspberry Pico or whether that's a minimum speed with MicroPython. That they were like, you can't go below this speed or it just doesn't work. So we'll find out. We'll go minimum clock speed for our RP-Pico. And we go explicitly defined, okay, but if you have a significant these even down to, okay, wait, what? So it appears that if we go below 12, we stop using the crystal and we have to start using a divider, which is going to start messing with things. So the crystal oscillator on the, I don't know if it's in the chip or on the board, is 12 megahertz. If we drop down to 12, that should mean we're using a 1-to-1 with the crystal, and that might be where we stay, because otherwise we have to drop down in like increments of divisor, I think. I don't actually know how that works. I would assume you'd have to drop down by increments, because you obviously can't divide by a half on a crystal oscillator, because it has like, how the fuck does it calculate that? You might be able to. Like, it's not, this brain's no way. Like, you can't do. My plan for displaying the game is I've got an e-paper display. It's it says 2.9 inch, I assume. It's a 296 by 128. It has an abysmal refresh rate of apparently 19 seconds, so I'm hoping it's got that partial draw that some e-papers have, but apparently it's only the black and white one, so I might have to get a specific one. This is just one that I had laying around. It's for a project that I want to keep, it's like secret's the wrong word, but like I don't want to publicize what it is because I think it's going to be fun doing it myself, and I don't want to necessarily spoil myself by like telling people and then someone be like, oh, here's a video of someone else doing that first. So it's gonna, we'll release it to GitHub when that project is done. Oh, we're down to 7, and that's with the LED on. It's 5 without the LED on. 5.7. Okay. Yeah, I'm just trying to find the actual. No, it's trying to like, find the exact thing that I've got. I don't think this is logged in. Cool. Okay. E-paper. How did it know I was going to search e-paper? Somewhere, one of these. One of these. Yeah, so I am hoping that the 19 seconds is just like a horrible overestimate. Hilariously, it may need to actually be 19-second refresh rate because of what I've got planned. Like, my intention is to literally go like as low a power as I can possibly get away with because of how I'm going to be doing this. And it's going to be so stupid. It's probably going to be the stupidest thing I've ever done. But the point of it is that it's a like somewhat viral bait idea of being like doing something incredibly stupid that nobody actually needs done, but like you always see those videos with like millions of views that it's like someone did something that, why would you do that? Here we go. So e-paper display. I've got a black, white, red one. Like that's like identical to the one that I'm holding in my hand right now. So I have to work out how to drive them as well, which is gonna be fun. But they did have like a GitHub linked when I was looking earlier. Yeah. So hopefully that just tells me like what communication thing I can use. But I was reading through all sorts of stuff and I'm a bit worried because I bought these over a year ago and they say like, oh yeah, don't, like you have to use them within 30 days or they can just burn in with the display, because this is not a picture. This is like they program the display to show this and then they ship it. So there's like a not insignificant chance that this may just be stuck on the screen forever now because I didn't turn them on and like erase them. And so you reckon every like 30 days you've got to like turn them on, clear them, reprogram them if you're going to do this. So this is the black and white model is about 3 seconds and they're 19 seconds, so that's going to be fun. Oh, that's on a different screen. I missed some of your messages. Old green LCD. Wait, is that... Are old LCDs persistent? Probably should. The issue isn't necessarily the programming something to clear it. Like obviously I just need to look up the library because I've done displays before, never ePaper, but it's more just I never got around to programming up my Pico to just clear them. But yeah, so the big issue that I'm going for, like, and the reason I'm not using an LCD, because I didn't realize LCDs were persistent. I assumed LCDs were like if you didn't power the LCD, the crystals would all relax and it would go back to being. But I guess it kind of makes sense that if you twist the crystal, then they would stay twisted until you stop complaining, until you swap the voltage back. But the idea being that, like, this is such a low power situation that I'm planning, like, because again, it's so stupid, but I want to make the video, like, I'm planning to do it this weekend, so hopefully there should be like shorts or something coming out that's like showing what I'm doing. But the idea is, like, I want to be able to, like, maybe charge up a capacitor so I can turn on the ePaper right to it while the capacitor is discharging. Like, the amount of power I'm going to have is going to be so tiny that I can't really afford anything that needs persistent power to maintain on, because at this point I may have to turn the fucking Pi down to 200 hertz and just like do everything really slowly, which if it's only got a 19-second refresh rate, I've got 19 seconds to process a frame. But I should probably also plug the ePaper in, because yeah, all the stuff I was reading about ePaper is like you can't even leave them connected to power. They reckon that if you're not actively writing to the screen, you should either tell them to go to sleep or unplug them, because they would burn in really bad. So ePaper is like terrifying technology for someone like me that's like always gets halfway through a project and drops it. Anyway, we should probably read the docs, maybe. Tools. It's gonna all be in Chinese. Okay, so I don't actually know which one I have. I'm assuming somewhere it's got written on it. Bio something. It really doesn't. Okay. Wafer. I'm assuming I've got the 8-pin. That seems like what I've got. This is the one I've got. What do you actually, like, what's your model? ePaper model. Digital humanities stuff. Okay, that's cool. Yeah, I wish I could get into AI, but like, I was really interested in AI back when, before AI was like the thing that everyone talked about, and was like, there was like a Sony like neural network desktop thing that I got working once that was kind of cool, but like you could only really train it to do like really basic stuff because it wasn't very optimized. But I just never managed to get my head around actually programming anything. And then, weirdly enough, a lot of the stuff that I was like, I want to try this as like an idea to optimize stuff, and then 3 or 4 years later, like, we did this, and I'm like, oh, I thought of that years ago, because I was just like, that would be a cool way. Like all the stuff they're doing, like the expert stuff where they like specifically tweak a model into a certain direction and then use that when the other model prompts. I'm like, that's something that I was thinking about doing like ages ago. Not that scientist wasn't on top of it and I hadn't just heard it somewhere, but it was just like one of those things that I thought to do something like that. There was also one about they discovered that if you train like a really large model, you can then train it again, but with like 10% less nodes. What are they called? Layers, or I don't remember. My brain's gone to sleep. I need to drink more caffeine. So the idea is that you could train a model that was like a billion parameters, and then you could train one that was 900,000 parameters. But what you do is you remove the parameters with the lowest weighting from the original model, and you give it exactly the same initialization state as you did the billion parameter model, but with those 10% of models removed, and then it retrains and it would be just as effective as the billion model parameter, because the idea was that you were sort of like basically taking like lots of shots in the dark, and the best model would win because it would train the fastest and then dominate the. So the things with really high weights were the winning model. So you could remove all the low weight stuff, run it again, and use 10% less compute to retrain it, and it would be just as effective. And it went all the way down to like 4% of the original model size, and you still got the same results. NPL model. Oh, okay, that's cool. There's a lot of cool stuff that you can do. I like the idea of like LLMs with programming, because I've noticed that a lot of people use LLMs for really dumb shit where they're like, oh, but look, they're not reliable because they just make shit up. And it's like, yes, but it's because they're not designed for factual stuff. They're designed to do opinion-based stuff, where programming makes it really... All right, okay. I'll wait for you to get back before I continue the thought there. Anyway, I'll read documentation while you're gone. That's the connector. So what? How am I supposed to know what model this actually is? So, I don't know how to tell which model it is. Maybe if I just click on the thing and show me a picture and be like, yeah, that one. Okay, well, it's definitely not that one. Because that's too big of a resolution. This one? This is 200 by 200 gate red active matrix. Display drive with controller. It could be that one. Is that? No, because it needs to be 300 going. Oh, I mean, possibly. And it's 400. Yeah. Yeah, that's what I mean though. It's like they're really good at programming because programming has those strict rules. Like the issue is with LLMs, and like if you ask them about something that like they don't know about, and they're apparently trying to train them away from this, is that they'll just make shit up. And it's not that like it's not the AI's fault, because it's literally just making shit up to begin with. It's just that like it's been trained on so much stuff. It's actually really good at just making up shit that's true. But like the idea is that like with programming, it can make shit up, and then the compiler goes, you know, that doesn't work, and then it can give it back to the LLM and it goes, oh, well, I'll change it to this so it works. And it's like they're really good at programming. But I agree with you that like just dumping it into a thing and executing it is maybe not the smartest idea, but it's also not super risky because let's face it, even Windows Defender won't let you write your own programs that will do malicious shit to your computer. Like I've written programs intentionally to like do something that like a virus may want to be doing. Like I wanted to like rename a bunch of files, so I was like, I wrote I had my own parser that would like read all the files in a directory and like rename them, and my virus scanner said, hey, like it looks like something's trying to like steal all your shit. And I was like, yeah, okay, I did write a very virus looking piece of program that just like went and tried to read through all my files and just rename them, and so it triggered it. So like you're not likely to run an LLM and have it do something that it's not like actively malicious. That doesn't mean that it mightn't brick your computer because it accidentally set some bit in the registry to something that you can't now change back. But actively malicious is going to be difficult for the LLM to slip it in, because the virus scanner will still detect even your own custom written programs as viruses. 6. Well, there is no page 6. The fuck? Okay, so as this so So that's the display driver. So I'm assuming that's the chip on the back more than that's actually the... Okay. Which means that, again, it's going to be even harder to work out which one I have. Do they? Okay, well, I guess it's because I'm running them outside of Windows. But my IDEs always pop up being like, hey, you're trying to do something like access the internet or something like that. And it's just like, you can't do that. I have to allow it through, which I guess is more the firewall than Windows Defender. But like Windows Defender's definitely picked up on shit that I've written. I guess it's more because I've tried to run it outside of when I'm developing it. I'm like, I want to use this program that I wrote. Yeah, I actually know 100% that like autistic thing of like I need to know why it does what it does or what I'm doing. It means that I'm really bad at writing programs because I have this like what's the thing? It's called like not invented here syndrome of like I don't like bringing in someone else's library even though it does exactly what I need it to do and it would be like just give it some bits. It's like no, my brain has this thing about like I need to know what it's doing, how it's doing it, is it actually optimized or are they doing it in a horrible way? Like my brain is like, yeah, I must know how they're doing it so that I can know if I want to be trusting their code. Like the thing with Bevy is that like I've looked through enough of the Bevy code and like enough of the updates to be like, I know that they're doing the most efficient thing so that I can fuck up on my end and make it really run like shit. But I know that it's not Bevy doing something in the background. So I don't try and like kneecap myself and Bevy by trying to optimize my code in the assumption that I'll be able to like sneak something past Bevy. Like I've done that with other programming like things that I've been working with. Like I tried to do it, I think with the Unity was like one of those things where it's like I would try and write my code in such a way to avoid Unity clobbering it. So it's like now I'm trying to write code that I assume will be more efficient. And I did that a lot with the voxel, this voxel shader. It's just like, it turns out the compiler is just really fast and it was better off just to write the most human readable version and let the compiler optimize it, because no matter what I did to try and make it faster, it was not faster than what the compiler was doing. Admittedly, I did discover that it's actually more likely that the benchmark is getting optimized away at some point, because I was messing around with something and went, this will definitely make it slower, and it didn't, which means that the compiler has removed whatever I changed entirely because I added extra compute and it didn't get any slower at all. And also noticed that like if you didn't run the benchmark for like 30 seconds, it would wildly swing. Like it was like 50% speed change but from run to run. Whereas if you run it at I think I gave it 50 seconds and it was always consistently really fast. And I'm assuming that's because it was like the thing that's making it slow is branch predictions missing. And it's like if you run it enough times, the branch predictor now like just 100% gets the branches right because it's the same branch run every time because it's using a seeded chunk, and you kind of have to use seeded chunks because otherwise you might end up with a really shitty chunk that makes it random. But yeah, I think what was ending up happening is that it was just like the branch predictor was getting so good at predicting that it was literally like optimizing away part of the code because it was like I know what number's coming next and would prefetch it because it was always the same number next, which means that when you actually use it in real code, it doesn't work nearly as fast as the benchmarks say because the benchmarks are all optimized for running exactly the same mesh over and over and over and over, when in reality, if you were using purely random meshes, it wouldn't be nearly as efficient. That's not my one. One of these will be mine. It's all in Chinese anyway. I don't know why I'm... Is this my one? 128 by 2... Yeah, this one's my one. Okay. So, how the hell do I talk to you? Active display with interface. In 1-bit black and white full display capacity. Wait. So it says it's just black and white. That doesn't... Mine's got red, so... I'm assuming this one's black, white, red. And it's just not... It's probably like... Because when I was reading the other chip, it was like there's 2 buffers, so it's like the red's actually a second display. The display is capable of displaying images at 1-bit white, black, full display capabilities. The model is a TFT array driving electric display. Timing control oscillated DC something model. portable electronic devices such as, okay, yep, But how do I talk to you? Is it SPI? I mean, I'm assuming this is, maybe this is the one I have. This is gonna, I'm assuming this is just a different size because I see there's a 20, this is 200 by 200. This is just, yeah, this is a different size. So my assumption is that if I multiply 200 by 200, which is going to be like 4,000, 40,000, and then if I multiply 128 by 296, yeah, so it's the same. Like, the reason they picked those two resolutions is because they're basically the same number of pixels, which implies that I just need to know which one of these I'm talking to. So 200 source active matrix control, and then what are you? You're so 400 by 300. So it can't be that one because that one physically does not have enough space. What are you? And you're 176, which is, and 296. Okay, so it could be this one because that one's actually physically like large enough. 276 source. Okay. How do I talk to you? Why do you not have the entire documentation? Why are you like stop? Oh, more pages. That's why. But how do I talk to you? SDA, SDA, clock, DC. Right, so okay. So I'm assuming this is the chip that I have to talk to, and then I'm assuming that I can just send you the right number of bytes. 6, a functional block diagram interface. Can support 2 or 3 wire. I'm in 4 wire mode because I can see the jumper connected. Selected position shows. Okay, so 4 wire. Okay, so okay, so pin is selected by BS1. Okay, right. Which is what that jumper is, I'm assuming, because it's got the thing on the back that says 4 wire, 4 lines, 3 lines SPI. So I'm in the 4 lines one, so I'm assuming that's just that pulls that low, and if I put it on the other one, it'd pull it high. It's a 9-bit SPI. Okay. So then pin names is reset DC. Okay, so the DC is only available in a 4. Okay, and then SDA. Okay. I'm curious how much power it's going to draw when I pull this low. The assessment. Okay, so MC serial interface. Okay, so it's a serial clock, SK, serial data, SDA. Okay, DC and chip select. This control pin status is 4 ones. Right command data is shown in table 2. The right proceed 4Y SPI is shown in table 6.2. Okay. So command bit, right command. So pull that pin up, command bit, pull that low, right data bit. Okay, while that's high, okay, right, so L is connected to VSS, okay, and H is connected to VDD, yeah, it stands for rising edge of signal, okay. SDA right mode is shifted in to an 8-bit shift register on every rising edge of the clock in order 7, 6, to 0, okay. This is SPI, which is similar to I2C, but SPI is significantly faster, but you have to dedicate a wire to every device you want to talk to. So with SPI, you have to pull chip select low, and that means I'm talking to you, and then you can talk really fast down the line, whereas I2C, you have to pull the low, then send your 7-bit address, and then if there's someone on the other end, they will start listening because that was their address, and then you send the data. Whereas SPI is I pull it low because I know that you're the one on the other end, and then you can share the actual clock and data bus. It's beeping at me again because I haven't touched it. So it's similar, but SPI is much faster, but and longer range, if I remember correctly, but it requires a dedicated wire for every device. It's the drawback. So you have to have a dedicated wire. So when we send data, if we have the data, okay, so hence the DC, data command bit. So if it's set high, we're sending data. If it's set low, we're sending a command. Okay. in the read operation command, okay. Command after is pulled low, the first byte sent is a command byte, DC is pulled low. Okay, after command byte sent, the following byte read as data bytes, the DC is set is then pulled high. So does it pull it high or do I pull it high? Okay, SDA, right. Oh, well, it's turned off. Hilariously, it's still blinking. I would have thought when the multimeter turned off, it would have gone to high resistance mode, but anyway. Yeah, I guess, I don't remember how SPI does it. I2C does its, I2C has a clock and a data, doesn't it? That's I2C. I believe I2C has a clock. It's got 2 extra wires because it's got a slave master out, slave in, and a slave out, master in. So it has a send and a receive and a clock line. So you've actually got 4 wires, and that's why it's saying there's a 3-wire mode, which is that you assume that nothing else is on the network and it's just always listening. So you can basically, like, if you just pull chip select low and there's only something, you can use 3 wires. Because you can just do clock and data out, data in. So it's SDA, no, where? That's confusing. But there's definitely a clock. I guess this doesn't have it because that makes even less sense because then it wouldn't need the 4 wires. Yeah, I think it's calling it 4-wire, but it's not actually using the display never writes back, so it doesn't have a 4th wire. But technically, this then has a command bit wire, which is not related to SPI. Like the DC wire is not actually related at all. The DC wire is something else entirely. It's specific to displays. It's a very common thing that I see all the time when I'm working with displays. So I'm assuming it's like a specific display driver chip did it, and now they either all do it or everyone uses the same display driver chip regardless of what the display is. Because I've got little round displays that are LCD and OLED displays all have it as well. So it's one of those, like, I think it's just either standard or they all use the same driver chip because it's cheap. Okay, so after chip is pulled low, the first byte is command byte. Okay, DC is pulled low. So chip select, DC is pulled low. Okay, so then the first 8 bytes are written. Then I'm assuming that's me pulling it high. And then and then 8 bits will be shifted out on every. Wait, what? And 8-bit data will be shifted out on every clock's falling edge. You can't shift 8 bits on a clock's falling edge, but okay. I'm assuming it's 8-bit data. Okay, anyway. The serial data SDA bit shifts sequence is 760. Okay. Figure 6 to shows the read procedure. Okay. Okay, so SDA, write mode. SDA, read mode. That's even more confusing because you're not supposed to have a read and a write mode. SPI is supposed to be like 2 lanes of communication. You can talk while also receiving. Anyway, serial proof interface. The 3-wire consists of a serial clock, serial data, and a chip select. The operation is similar to 4-wire SPI, where DC pin is not used and must be tied to low. The control pin's status is 3-wire SPI, shown in the table below. Weird. So do you lose a bit of data because you've got to write a 1 to say that I want to read? Hey, that seems like it was. No, it says it's 0 1 and it's anything. So that's even more confusing. So I don't know. Okay. In read operations, SDA transferred to the in the 9 bits. After pull low, the first bit is a command bit, and then this. Okay. Right, so you send a 0 to say that the DC would have been 0, and then you send a 1 to say it would have been high. Okay. To command bit is sent. The following bytes, data bytes, which TCS bit is 1. Okay, right. After this bit sends for MCU, an 8-bit data will be shifted out every clock with falling edge. Again, that's terribly phrased. This serial data CI-bit shift sequence. I'm using 4, so I don't know why I'm spending them away from timing and analog operation. Boosters and regulators. Okay, nope. RAM. Okay. Okay, so data bit in RAM is 0011, and then data bits in black white RAM is 0101, which would be black white red. Huh. LUT 0 for driving black, LUT 1 for driving 0, LUT 2 for driving red, LUT 3 equals LUT 2. Yeah, okay. So it can't be. But I don't know what the LUT stands for. Yeah, SCL is the clock. Yes. How to start learning how to code in today. To be honest, like, this is something that I've noticed talking to people about learning to code, is find something that you actually want to do with code, like a problem that you need to solve, and then go and try and learn how to solve it. So if you want to make a game, like, then once you've got a game idea, go learn how to write the code for that game, watch YouTube tutorials, that kind of thing. Because I've noticed a lot of people really don't like programming because it takes so long to get to a point where you can do something that you just want to do. So if you don't have something that you're trying to make, it's really hard to learn to code. Like, my issue is that I learned to code because I like the idea of coding more than I had something that I needed to code. Whenever I've had someone go, hey, can you make me this thing? Or like someone goes, oh, can you do this specific thing? I can program it 10 times better than when I'm like, I want to make this nebulous idea and try and work out from there. Like, if you have a goal, do that, because it makes it so much easier to learn specifically what you need. Like, pick a language based on what you were needing to do, not like I did, where I went, oh, Rust, I like the philosophy of the language, I'm going to learn the language. Like, I didn't learn Rust because I had a specific problem to solve. I learned Rust because, to me, Rust is an appealing concept, which means that I have not necessarily progressed, like, projects solved finished wise as much as I otherwise would have if I had decided to do programming specifically to solve a goal. Instead, I spend a lot of time making what I consider to be the correct piece of code, because it's, to me, more appealing than writing an actual functional program that does things. Yeah, there's the other option, is just go to school for it. I tried doing that. I went to TAFE, which is Australia's trade school for information digital media technologies. I got a cert. Well, I went to get a cert 3. I already had my cert 2. I did that in high school. Then I went to get my cert 3, and that was hell, because we had one lecturer was in his 20s, 30s, and he was teaching us the concept of, I want to say, computers aren't fast, you need to write fast algorithms, whereas one of the other lecturers was in his 60s, and he was teaching us you need to make memory efficient programs, which in the modern day are both wrong, because when you write JavaScript, you want small programs because it gets to the user faster. So it was this confusing thing of the actual stuff you'd be using in production code these days of JavaScript is make the JavaScript as short and concise as possible, without obviously making the code unreadable, because you can run it through obfuscators that crush it all down to single letters, because you send the JavaScript as a text file. The smaller text file, the faster it loads. NeoVim. I have issues with Linux, and partly because I have that issue of I try to do things the hard way, I guess. Not intentionally, but sometimes intentionally. But I tried when I tried to learn Linux, I tried to do it like dual booting it from a USB, because everyone was like, oh, you can just run on Linux from a USB, like you can boot your server. And you know, I was, oh, that's cool. Like I can have a USB that when I plug the USB in, I run it on Linux, and then I can like run my Windows off my hard drive when I go back to want to just do Windows stuff. And that was hell. It crashed multiple times. It corrupted my boot sector to the point that like I was using, I think it's called Grub, to boot my computer back into Windows, because like the USB wasn't plugged in. It just wouldn't boot. It would just boot into Grub, and I had to navigate through the file system. I had like basically a sticky note telling me like what file, like what string to type in to boot into Windows normally. And then at some point something went terribly wrong, and it wiped my whole computer. And then that got us the Zero to Pong series, as I fucked my computer so completely that I had to factory reset it and reinstall Windows. So I haven't had much luck with Linux, but that's purely because I am an idiot that takes Linux to like I push it in the wrong direction, not the direction Linux is supposed to be used, and I'm not tech savvy enough to make Linux work the way I want it to work. So, and I have issues with Vim in that I'm too dyslexic to use the key binding stuff, like where people navigate with the keys, because like I can touch type somewhat, but then my brain will flip B's, P's, like, and it doesn't even make sense because I'm typing. Like it's not like I'm writing the letter upside down. Like I literally will put B's where I would be wanting to put P's and stuff like that. My brain just flips those letters and treats them as the same letter. So B's, P's, D's, like the other letters that fucking look the same. So I end up typing words with those letters in the wrong places, and I'm also just terrible at spelling. But it means that that kind of yeah, I've learned that now, but I want to go back to Linux, and maybe I should now, because apparently Steam's done a lot of work. That means that my like thousands of dollars of games will actually run, whereas for a while there it was like if you boot on Linux, it's like you can't run most games, because like a lot of games it was like they had a dedicated Linux build, but it's like a lot of like the bigger games and also some of the more indie games, like the ones that didn't blow up, or like they didn't have Linux builds. So there was that, like that's why I wanted to keep Windows. I didn't want to jump in and go full Linux. Anyway, we should focus on programming. I'm terrible at looking at distracted. Programming wave from gate source and beacon. The fuck? I don't actually know what this is trying to say. There are 12 groups, group 0 to 12, and each group has 4 phases, A to D, 2 state repeats. Okay. Totally, there are 448 phases. Okay. Yeah, I don't know. Maybe I'll look into it again. I just, like, it was such a pain last time I did try to do it. That was, like, I think 2020 is when I was doing it. It was just so painful that I'm like, I don't want to go back, because I feel like I'll fuck it up again, and then like I'll lose my hard drives again. And it was, yeah. I probably should, because, you know, like I'm a YouTuber that's like supposed to do that kind of stuff. That's like, nah, it terrifies me to no extent, like to no end. In addition, in each phase, the phase length text can be set by the number of frames from 0 to 2 frames. Also, each group can be repeated with repeat count number. Oh god, I can be repeated with state repeat count number. Oh my god, what the fuck? What do you think the odds are that this chip just has a driver for it? Like how? This is no, it wasn't this one. It was this one. So let's go. Is it Rust display? Right. Embedded display. Embedded display crate. I need to like work out what embedded graphics. I think I need embedded graphics for something. Like embedded graphics lets you like make this kind of stuff, but I need to still work out exactly what embedded graphics called. Draw target. To support many different kinds of displays. It doesn't divide. Yeah. Okay. So, okay. Okay, so we need to work out, okay, well, one of these. So what is it? It's the, is it the SSD? Was one of these say SSD? Control F, SSD. Oh, look, there's a bunch of SSDs. Okay, so it's SSD, I think it was this one. I don't actually know though. Nope, that's the 200 by 200. And this one's 400 by 300. Is it this one? So this is SSD 1680. Okay. Do you have a 16? Nope, you don't have a 1680. Okay. So let's go Rust SSD 1680. Well, there's a e-paper display that used, well, I don't have that one. I have the other one. So does that mean I need to try a different one of these numbers? It's definitely one of these numbers. 181. No, this is apparently used in the one by vintage display. So we'll just try the final number, which is 3. That, or it's apparently there is no 3, so that's terrifying. Well, at this point we just wait. I'm gonna get this one. Well, it's the right company. It's just the wrong. Well, it says it's the same with the 2.9, so I'm assuming they probably both use the same chip, maybe? I don't know. Considering that on their website, like the 80, this number is bigger than my display even. Like mine's 296 by 128, and this is 176, so this implies that this can display even bigger again. An internal temperature sensor? Oh god. Okay, well, let's just go with the where were we? Here. So we'll just copy this crate and just include this down here somewhere. Dependencies. Gonna go down here. News. There needs to be a comment. New stuff, just so that I know what's broken if something breaks. Let me just equal wildcard. There we go. Okay, SSD 1680. Okay, and we need to say I don't think they've got it, which means we need to go like embedded graphics. It's surprising that worked. It seems to think there's 09. This seems to agree that there's a 09, but it says 08, so I'm extra confused with that one. We're just going to pretend that didn't happen. All right, so I need to actually plug this thing in. Busy. I don't know if Busy's actually going to connect to anything. We then have reset. Again, I don't know if reset's actually going to end up connected to anything. We'll have to find out when we pull in the driver, because half the time these drivers don't actually do half the chips. They don't connect half the pins because it's like they're not normally needed. Okay, DC. We're also certainly going to need DC. So let's plug DC, and then we're going to go Pico out. Pin out. Pico pin. I gotta stop opening like a million of these. If you go through like all my open tabs, like half of them are the pin out Pico, like just pictures of the pin out, because like I just open a new tab every time instead of like just going back to the tab that's already got it open. Okay, so we're gonna plug it in and we're gonna say it's gonna go. All right, let's make the display. So we need to make a resource. Okay, maybe we should make a module first. So mod display. Okay, so then we can make it like agnostic for later if we want to swap out to a different display for testing or something. So then we say we need to use Bevy. Bevy preload. Okay, and then we're going to go drive. Ooh, yes. Struct. No, struct display. Right, like this, and then this is going to contain a display well, I guess it's a driver, which is going to be a was it? What was the crate called? S something. SSD. Right, I'm going like I remember the acronym SSD. That's too many S's. SSD. That doesn't seem correct. Why is it not showing up? 16A. That's too many S's. Why can I not see you? Why are you not working? Did I not save this? Is that why it's not working? No. Why can I not see you? SSD. Why? Is it because I'm in something? Wait, why are you not saving? Why do you keep telling me you're not saved? Okay, now you are saved, which means the display is now in the path, which means that you should now be telling me, like, this exists? Nope. Why are you not working? Is it because it's running? Am I just disconnect? Do you start working now? Maybe. Nope. 1680. Still not working. Okay. I need DC because mine's configured for 4-wire mode or 4-line SPI, and that means I use DC, whereas if I use 3, I would need to well, apparently send an extra bit that then tells it what the pin would be. Why are you just not turning up? Like, did I not save my TOML? No, I saved my TOML. Is it not called that? Maybe like it's getting confused because it's the crate's actually called something else. No. How do I go to? Nope, not here. Crate style. Well, apparently it's 0.2, which was pasted in there. Well, okay. We'll cargo check because I don't want to. I don't want to flash my my Pi over and over and over. I don't think it's good for it. I don't know if it's bad for it either, but so selection requires embedded graphics greater than 9. Okay, well that's part of the confusion, is that apparently the embedded graphics 0.9 doesn't exist, despite this thinking it does. Now I've only got, oh, okay, so that was the problem, is it was failing to pass the TOML, but it wasn't actually passing it as an error. All right, so color driver. Color. Okay, so I'm assuming when it says color, it's referring to like the actual color that I send, black, white. Okay, yes, very useful, especially when the display has red as an option, so that seems concerning. Yeah, docs does say that it's red is supported in this particular model, the 80, right? It says, yeah, red, black, white. So I don't know why the driver crate doesn't have red as a color, but anyway, we're gonna go, oh look, it's got graphics. Display 2 in 13. Okay. Graphics, no, driver, that one, and then it needs the SPI busy. Oh god, well that seems like it's going to be complicated. Yeah, I know, that's what I'm saying. Like, it was weird because it gave me a check mark, but then also told me that, like, he's got all the versions. And it's like, yeah, no, it's a check mark, but it doesn't actually exist. I'm like, what the fuck? It probably means that there's like there is a version, or maybe it's because I've got those the overrides down here that it's confusing it, that it's thinking that maybe I'm referring to something that's inside one of those overrides. But I don't know. Yeah, it's very weird that it does that. Okay, so this is terrible. So I need SPI. Which, is that the bus or is that the type? What the fuck kind of... Okay, so your display interface, which needs an SPI, which I'm assuming then needs an SPI driver, which is embedded how SPI, okay. Too many generics is what this is, too many generics. Okay, so we need to say something along the lines of use in... Nope.
Embedded hull SPI nope. Oh right, because SPI is a type. Okay, so then we need to go MCRP SPI like that, and then we need to say annoyingly I need to go back to the thing and work out which SPI I'm going to, and apparently I'm going to be using SPI 1, I guess. TX, I think? TX, yeah, TX is transfer if I remember, and then clock. Okay. And then we can chip select 1. Okay, so that means we can say this is SPI, and then we need to give the SPI some information. We'll call it static. I don't know if it is going to be static, but then we're going to say the instance is going to be MCRP SPI 1, and the mode is going to be MCRP mode. I don't know. I think SPI blocking. We can't really do anything async, so we'll just call it blocking. Okay, then you're going to horrendously. Okay, so we're going to. We should probably define these in a different module and then use them because they're going to get really long and be really annoying. So we're going to say mod types, and then we're going to go. Don't comment it out. Oh god, what have I done? Too many keys being pressed. Okay, so type SPI, and it's going to equal embassy RP SPI static. Yeah. Okay. Cool. So then we go back to here and we go. Okay, you don't do this. You use crate type. Like so. We're in the live stream, so I can see if anyone's typing. So instead, we come down here and we say, no, you use SPI. So, okay, so you apparently can't find SPI in scope, which is just completely incorrect, but it isn't because this isn't public. Okay, cool. So then we need to pass you something else, which is the busy pin. Okay, so the busy pin, we go back to our pin out. What pin we're going to pick for busy? I hilariously can't pick the pin I was going to pick because it's part of the same bus set, I think. I don't know. We'll call it pin 11. So we're going to say type BSY is going to equal embedded embassy RP GPIO. No. Okay, it must be a peripheral. And then we need pin. Yeah, pin. Which pin? 11. Right, pin 11. So then that's our busy. Yeah, busy, and then RST and DC. Like so. Then we go here and we say, okay, so reset can't be 11, reset has to be like 10. And then I guess, can we use 12? I don't know. So technically we only need those 3, so we could use 12. But I don't know if it's going to like me setting an RX and a, we'll call it 9, not 19, 9. Okay. So why are you complaining? Because something about it not implementing debug. That doesn't implement core FM debug. The trait is oh okay, yeah, no, we don't need debug. Sorry, it's deriving debug for no reason. Okay, so that's our actual display. So we're gonna add in like import display. Yeah, like fn new. Which is going to be really weird. So we're going to add SPI. It's going to be okay. Yep. And then so actually you, sure. No, don't go implementing random things that I haven't decided to do yet. So then we need to go like driver is It doesn't like that. Okay, so we have to like return like a result, not a result of self and whatever bloody error you return, which is a I don't know what error, and now it won't tell me what error. What error does this function return? Sure, return a unit telling me that it failed. And then yeah, you just say okay. Display, and then I question mark you up. Okay, first off, is that even a function that I can call? Yes, this function takes 5 arguments, but 4 arguments were supplied. What the fuck do you mean? Oh, we need to pass in a delay, which is just embassy. I think it's embassy time delay. That we need a reference to something that is delay. Does that work? Okay. Right, so what error do you actually return so I can specify that return type? Display error. Okay, so this is going to be a display error. Which is SSD. This, you apparently prelude display. Wait, where are you getting display error from? What? Okay, do I have to go into driver? Display error, there it is. Okay, so you can return that. And then you're going to yell at me because apparently is not satisfied because it doesn't implement output pin, input in. Okay, so that becomes the fun thing of we need to go, it's out, output, new, I think. And then output. Wait, that should be an input, shouldn't it? We should also probably bring in the trait so that the type inference can start helping us. So we go up to top here and we say, hey, can you use... Yeah, that one. All right, that's correct. Yep, cool. So it's trying to say that I should do something like that. Cool. Okay. So you need to be like an input, don't you? Busy is an input, yeah. So you're an input. Yeah, cool. Alright. So you don't like that because it takes 2 arguments. Because we need to set its pull state. Okay. Busy. So I'm assuming busy should probably be floating. I don't know. Pull. None. Because I don't want you to pull. Can you please replace this with a path? That's not what I meant, but okay. So close. Pull. I'm assuming pull none because if I pull it, then it doesn't make any sense because I can't let it drive itself. Okay, so we pass it busy, and it's saying it can't do busy because busy expected struct parry. What? Pin. Pin. Wait, what? Is this not correct? How did I do it? I've definitely done it in the main because I'm blinking an LED literally right now. So how did I set up this goddamn LED? I said output new p.pin. Oh. Okay, so these are peristatics. That's so weird. Okay. Okay. So that means instead of being a pin, you're is that an embassy RP thing or is that? Yep. Static. Like that. Apparently, that's the correct way of doing that. So it's 11, 10, 9. Okay. That feels like the wrong numbers. 11, 10, 9. No, they're right numbers, never mind. So we pass in the busy because busy is a yep. Okay, are you gonna stop complaining now? No. But I've changed their types. Okay, whatever. We're just gonna set you in there. Pull. So output is pull. This is DC. I think I want to pull down. Maybe I don't know. Down. What's the default state of DC? Well. Okay. Reset. So let's fix that so that these can stop complaining. Why are you not rerunning the thing. Like, why are you still complaining? Let's go back to the documentation and see. It said something about these pins needing to be in what state. So power pin. Okay, chip select. So we probably want chip select to be pull up, and DC. This pin. This is this pin is reset signal active low. Active low. So don't pull it low. Okay. When not in use, VDD or VSS, VDD or VSS. Wait, what? So VSS is source, which I think means positive. The chip select should be positive pulled down. Command should be down pulled up. I guess. That's confusing. It's because this hash means not, I believe. So not low. Okay. Command bit usually low. I'm assuming the other thing will take care of that. I don't know. Maybe we should just leave them floating. Okay. No. Actually, technically, so reset needs to be pulled up, right? Because if we pull it down, it'll reset all the time on us. Why are you not working? Oh, because you need a level output level, right? Right, because level up, and then this is DCC, so this should be level up, a level high, not okay. Okay, so now it's just complaining about the SPI is not satisfied. The trait SPI driver is not. Okay, first up, why are you complaining? Because it's lowercase p because the AI is an idiot, and it's got an S. Okay. Lowercase p. Then we go down home. Control. Okay. Does that fix it? No, that's because that's not what that's supposed to say. You're supposed to say Perry. No, Perry. I don't know what these Perrys are, but I'm assuming just like an exclusive reference to peripheral. Memory efficiency is typically either zero sized or very small. However, is always 4 bytes instead of target, even if the T is zero sized. Huh. Cool. Code size efficiency. It's the same driver, both SPI4 and the driver code would monomer 2 times, whereas Perry, the driver is generic over a lifetime only. Become lifetimes don't create. Okay, that's cool. So we need to make sure that the SPI actually implements this, which apparently you don't. Now my suspicion is not that it's not working, like it's not implementing it. Alright, I might be still streaming when you get back, I'm not sure. But definitely like on another stream. It's good talking to you. It was interesting like conversations we had. I don't know, let's try to start still. So we need to go, well, maybe we should pop that type into our display because we're not using it anywhere else. Okay, so the issue I'm seeing here is that your SPI is not a driver. Okay. Well, it literally says SPI driver, which means that it's almost certainly a mismatch in the HAL versions. So we go cargo tree like it suggests, and we go, what goddamn version of HAL do we have? So we have embedded HAL version 1, and that's, well, actually, what? The display build dependency. Okay. So it's Oh, for SSD. SSD. Okay, so you use Embedded HAL version 1, whereas Embassy, I'm assuming, is using Embedded HAL, a different version. Embassy RP. Embassy dash RP. We go down. Okay, Embassy RP is using Embassy Embedded HAL and Embassy HAL internal. Embassy HAL. Wait, do you not use? Okay, so embedded Embassy HAL. I'm assuming at some point you've got to call embedded HAL so that embedded HAL version 1. Okay. So it's all the same version. Embedded, well, not exactly. What do the asterisks mean? See, that's annoying because apparently there's a 0.2. Why are you depending on a 0.2? Why is this just the wrong SPI maybe? I don't think it is because it says driver. I'm assuming at some point import SPI. No, let's look for SPI driver. No. Why do you? Okay, so embedded HAL. What is this embedded HAL 2? What is this? What is this? SPI. Divide rounding. Oh, SPI transfer. Blocking arrow right. So it doesn't implement SPI driver is probably the problem. There's a embedded HAL 1 SPI bus. What the hell do you want it to have? Like driver. SPI device. Okay. So my assumption is that I need to like wrap it in a device, maybe? I don't know, because it's got bus. But it's not a device apparently. Okay. So do I then go something like well, that's the interesting thing also. This doesn't actually get given any pins. So maybe that's the problem, is that I need to be like Embassy RP SPI. So blocking config. So there's an SPI, and if it's like new inner clock. What is this actually return? Maybe this doesn't return what I think it returns. You return self. So no. How the hell do you know what one you are? What? Okay, yep. Is this a different SPI that I've somehow incorporated here? Okay. Because like you don't keep track of, I guess it must be any pin. Clock pin T. Mossy pin T. Okay. Wait a second. You wrap them in sums, right? Yeah. Because I don't actually need to provide it. Wait, do you let me not provide it? Can I say something like, is there a new but something like new blocking? Right, new blocking is probably better. New transmit only. Okay, so that would still need inner. Still need clock. Okay. So I don't know why it's not correct. Maybe wait, you have not have a chip select. Maybe that's what the problem is. So you have a clock, M out, S in, TX, DMA, okay, config, right. Okay, it says in async mode. Okay, no. Why is that only working? Okay, just go. Okay, so we would need something like maybe it's embedded how SPI. So you only have the types, right? Which means like it's definitely not that. So is it embassy? RP time driver, no. SPI. There's no. Wait. I saw something. Spin lock, no SPI. So async blocking config error. See the SPI. Okay, so I can do SPI things with you, but you don't have a chip select. So I'm assuming that's what's wrong with you. So we need to go something like Okay, maybe we need to actually include so it's embassy embedded that's a real thing, yeah. But apparently you're only version 3, which is somewhat concerning. And then we want to come down here and we go like, are you going to pick up on it? Yes. No. Okay, there we go. Weird. Right. So, so embassy embedded how? Do you really have an SPI? Shared bus? Well, I saw something that was like SPI. Device error. Okay. So blocking. SPI. SPI drop. SPI device. So we need an A, which is going to be static, and a mutex, which is a apparently embedded. No, embassy RP. No, what would it be called? What would, so raw mutex, which comes from somewhere. Is it ink mutex? Right, no. Blocking mutex, raw. No raw mutex. Well, no, that's definitely not correct. So then you need to take in that, and then we get to here and we do that, and we go, your chip select is embedded RP peripheral pin underscore. What is your chip select pin? Chip select is going to be chip select 13. Okay, let's see what we get when we say 13. Have we resolved all the errors? Kind of. So cannot be shared thread safe with so what? Okay, so we'd have to give you a real mutex. That's annoying. Critical section raw mutex. Thread mode. Okay, a mutex that can only be borrowed from thread mode. Okay. I don't have no idea what it does, but so you're complaining still that so you're saying that the trait bounds digital output pin is not satisfied. Okay. But why? That's very confusing. So you're a mutex and a jux. So this needs to be a output. That's, I guess, it's static. And I guess you don't care about what pin you are then? Is that what you're saying? Because an output hides its pin. It's a flex apparently. So now flex, flexible pin. This pin can either be an input or an output pin. The output layer just a bit remains set when there's no output. So the pin level.
Interesting. Does that work? Okay, that works, and then that fixes that monstrosity. Okay, I don't know what this monstrosity is. So what are you complaining about? So you're saying that this is a SSD SPI device. Something, 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 something. Oh god, that is a hell of a type. Output static, input, output, output. Is that what your problem is? Is it your... Okay, so you're busy, which means you're an input, output. Is that what your problem is? Is that like they're just the wrong types? Okay, fine. Needs the lifetime specified. Is it all static? Not a static. Okay, static. Okay, so complex type usage. Yeah, I'm gonna get rid of that type. I just needed to know what it was so it would stop complaining. Okay, so we pass in our input output pins and everything. We have to pass in the correct SPI type, which is going to be a pain. We have to make that before we... Okay, that should be fine though. New associative function never new is never used. Yes, okay, cool. So that should be our display driver, which means we can come down here and go, hey, when we start our app, we need to go let display equal display dot display new. Now you seem to think you knew how to make our SPI bus, which is nice. Okay, so this is going to be our p dot, I don't remember what pin our busy pin was. Busy is 11. Oh, there you go. Apparently AI remembers. So then we need to go. I guess we can just, yeah, SPI and everything new. We need to say p dot. I have to pass in the SPI bus, which is then going to be what's the correct code? Embassy RP SPI new p dot SPI 1 clock chip is p dot pin underscore clock is pin 15, motherboard out in, which is TX. Oh no, so you're not 15, you're 14. Clock is 14. Clock is 14, and TX is 15. P dot pin underscore 15. Gotta go correct the spelling on that one. Capital pin. Okay. Wait. Can I make you a not new blocking TX? Okay, which means that you will have done something. Okay, you've just got too many things. Anyway, config, which is going to be I guess default. We'll just go like default. Oh, default. Okay, and then chip select, which needs to be a do I need to pass you an in? Yes, in put and then apparently that's busy. What? Why? No, your chip select is 13. I don't know what we're using 12 for, but you're 13. Pull. Right, no, your output. Your output, and you're set to level high. Like that. Why are you putting comments and stuff? It doesn't make any sense. So you're saying mismatch type expected reference mutex. Wait, what? Do I have to wrap that in a mutex now? Oh god, this is getting out of hand. You take in a mutex to a ref cell to a bus. Oh god, okay. Well, that's a lot of fun, isn't it? So static. Let's call it bus. And it's just gonna be a mutex. So that's our embassy sync. Embassy sync mutex. Mutex. Yeah, embassy sync mutex blocking raw thread mode mutex, and then your SPI, I guess. I don't know. No, that's not correct. God. Your type is out of control. I need to call that SPI. That's SPI, and then so that's SPI, and then this is going to be hub type SPI underscore bus, and it's going to be it's equal to that comma SPI comma output static, something like that. Apparently that's how I'm supposed to name that. That's weird. Okay. And then we go, you don't take in an SPI, you take in an SPI bus. SPI bus, like that. And then that fixes that, I think, because you need to be renamed to SPI bus. Okay. Does that fix this now? No. So what is your problem? You're saying your driver something input output when you got a thread mode okay, can we go, what the hell is this? So you have an SPI bus input output. Apparently it's output. Okay, the FBI bus is something a bit safe. So your embedded how share bus blocking SPI device static. I just keep highlighting. Does it keep going? No. So as soon as I get to static, it stops. Okay. So then comma and then thread mode. Yeah. And then SPI, peripheral SPI blocking. Okay, and then comma output. Wait, what? Oh, comma output, yep. And then your all of that, comma input, output. Okay, then why the hell is it not the same type? Please explain to me why you are not the same type. You are the same type. Okay, it was just yelling at me for no reason. Okay, so there you go. So we pass in the bus, the bis, and the bus, and the this, and the output, and that, and then we go, okay, are you the right type now? Function new. Oh, right, no, we were doing the mutex. That's what we're doing. So that's why I was making that thing. It's because we're going to say bus is mutex here, and mutex, thread mode mutex, and then SPI bus, like that. Okay, wait, equals embassy sync mutex new it needs to be a ref cell, doesn't it? Oh damn it. Ref cell. Where? How do I static cell? No, like that, and then we do like you're actually a mutex to a no, that makes it even worse. Is it a static? This seems horrendous. This is obviously not the right way of doing this, but I kind of want to get something working, otherwise this feels like a waste of time. Alright, so then, and then instead of doing mutex new, we say statics fucking new. Right, and then you're mutex to the SPI bus, which means we go here and we say, horrendous mistake being made. So we're going to say, bus dot, init, and this is going to be a the sync mutex new, and then the value is this monstrosity. All right, I think that's correct. Except it's picked very different numbers, but I think that's because it's trying to assume that I'm doing something different than I'm not doing. 14, 15. It's also it's new blocking TX. 14, 15 default. Apparently I've got 16, so 14, 15 default. Show it in the chat in case anyone's talking. Okay. So then we have to do some horrendous thing about SPI here being, you need to be like a mutex to a thing. Oh god, that doesn't make any sense. What? You take an SPI bus, and then the SPI bus is an embedded home button. All right. Then we call. Does this give us access to this monstrosity of a thing? Okay, then we say, you are an SPI bus new with reference to bus and a chip select, which is an output new. I don't remember what our chip select pin was. Chip select pin is going to be 13. P.pin underscore 13 with a level high, which is concerning because I don't want chip select to be high. Okay, so mismatch type. Why are you saying a mismatch type? Because you expected a referenced. Wait, what? No, wait. This is not correct. It's this, right? And then you pass in the bus, which means that you don't want to SPI. This correct? Because then you get SPI, and then we can pass in the bus, which is a mutex. Okay, maybe we should just make the mutex here. Well, you're going to stay. Now you need it to be static. Okay, then we're going to unsafe to do that. So that is how. So when we initialize you, when we call init, we need to say, right, we get access to static. Let bus equal that, which is then a static mutex, right? And then we can give it a reference to bus like that. And then you're going to complain. I think I have to dereference and then reference you like that. No, it still thinks that found a reference to embassy sync mutex. Fuck it. Thread mode ball mutex ref cell. Okay, it needs to be a ref cell. Fuck, this is getting out of control. Wait, so it needs to be a mutex to a ref cell. Ref cell. Wait, embassy sync. Wait, where? What type is ref cell then? What do you mean? Ref cell bus. So where is this ref cell type coming from? What is this? This is core ref cell, and what are we inside of? Embedded how? Okay, so it needs to be mutex embedded how ref cell. No, what the hell? Core? No. Excuse me. How do I do this? So we need to go here. So this is SPI bus, which is the that's embedded how. Oh, embassy embedded how. So embassy embedded how. Nope. Where are you pulling this type from? So we're inside embassy embedded how, and then ref cell comes from core up. That's Rust core. Okay, core cell ref cell new. That's too many layers of nesting. This is horrendous. So you need to be modified to be a ref cell then. So you need to be a core cell ref cell. Okay, so it's something like that. Not quite, wrong spot. It needs to go there. Why is it too many commas? Takes one generic argument. Even struct takes one generic argument. Mutex. Wait, did I have that backwards then? So mutex and t. But I fixed that. Have I got too many commas? What is your problem? Okay, now it's working. So then why are you still a mismatch type? Because your ref cell block, they look like the same type to me. Expected reference thread raw ref cell SPI static SPI1 blocking, and it found reference. They're the same. What do you mean? How are they a mismatch type? I don't think you'll like it because it's mutable, which means you don't like that it's mutable. Yeah, you don't like that it's mutable. But if I downcast, can I as ref? No, can't as ref a mutex. Okay. So a reference to the dereferenced value is the only thing I can do, and then you're telling me that it's the wrong fucking type, despite them being identical types. Okay, so you're saying you expected to find a static SPI1 blocking full names. Okay, what the hell is the full? Like they're the same fucking name. Expected. Okay, expected mutex thread mutex found mutex. Okay. But what do you mean they're not the same type? Weird. Okay. Fine, we'll do it I don't know if it's going to help because we're just going to end up with the same thing again. So let's get rid of the static cell then. Let's just say that you are now equal to this. So you need a T. Does you take T? No. So T goes like here, I think. So then it's yeah, it's not like that. Right, then you work, and then we just give you a reference to bus. And since you don't actually need, okay, now what are you complaining about? So you still don't think they're the same type.
But how are they not the same type? Like they're like letter for letter the same. Consider using to print the full name type in the console. Okay, so that's in here, debug. Where are you saying the full name? So I'm assuming if I go to the full name, it's going to be fucking written somewhere and it's dumb. Depth. Oh god, this is going to be hell. What do I need to track down? I need to track down AF. It's like a hash or something that... Oh no. They're all identical? Okay, which means I need to pay attention to the end, which is ends in 69. That one? Embassy, SPI, blocking, output. Is that what the problem is? Yeah. No? So you want a ref cell and then a chip select. Oh god, there's just too many. It's just the same name over and over. It really should clean up these, because if it's... I don't have any idea which one of those it's actually going to be. Can we just get rid of like all of them and then get it to like redo it? Oh god, there's just so many. One of these, move to recycling bin. Find all of these, like move to recycling bin. It should clean this stuff up, because I don't really care if I compiled it fucking 10 tries ago. Now I gotta try and get it to like redo it. Interesting. Alright, so why are you complaining? You say something about it being written there. So is there a really long thing with the text? The answer is no. Can I... Oh, no, not free. Cargo check. That. Let's see. Okay, so... Well, it did actually print out a longer name. So, wait. Oh, there it is. Because one's... Alright. It's like, well, found the issue. Which is, I guess, why it was saying print out the full name. I don't know why it was printing it. Embassy blocking mutex, so I just called it a normal mutex. I wonder, I think I need a blocking mutex, because if I don't use a blocking mutex. If I called it a blocking mutex here, I called it a blocking mutex there, I called it a normal mutex here. No, blocking mutex. There, they're the same type now? No, apparently not. So embassy sync. Okay, let's check again and go. Now what do you say? Okay, did it not save? Now you're saying it does not live long enough because it needs to be a static reference. Okay, so then we need to say let bus equal unsafe. Then we need to call std. I know it's core, isn't it? Core mem transmute bus. Okay, and then I need to give you like a type inference, I think. Yeah, so I need to know what your type is, which is underscore, and then you need to transmute into a static and then underscore, because I don't get. Okay, so okay, there we go. Wait, what? No, can't do that. So how do I specify? I don't know. Well, I guess the oh. Wait, what? Uh, oh, but like, what are you actually saying I need to include? Okay. Help. Consider adding missing annotations type. Oh god, no. That type name is too long. Okay. Then you work, and then we need to go insert dot insert resource display. Okay. Wait, what? Oh, because you're a result, so we need to go something along the lines of unwrap. Because I am lazy. Unwrap. Okay, and then why are you saying this? It's not a resource. Yeah, but it's because I unwrapped it. Can you like, yeah, okay, cool. So now you don't like this because the trait bounds digital format is not implemented for display. Right, okay. Do I have to turn that feature on maybe? Maybe. So version equals this, feature equals DEFMT. I'm assuming that's what I have to do. I don't know if it's a feature of that crate, but okay. So I've hit F11 at some point. Oh, wrong tab. Okay. If we go back to here, we go here, we go, hey, do you have like versions and then features? Nope. We just have graphics, so it's not a feature of the crate, which means it's probably going to be yelling at me that it can't do it. Okay, so right. Are you just exporting a type? I don't know. Okay, wait. That seems extra confusing because that tells me that that error went away, or is it just not compiling? Okay, it's just not compiling. It's weird that it doesn't tell me that there's an issue inside the TOM. Okay, anyway. So you're saying I can't unwrap it. Okay, so fine. What we would do is we say if let match this, match what? Oh. Display image. Okay. Mismatch something. Okay. Then we need like a semicolon here. Yeah, you don't implement display. I don't care. Can I do anything with the E dot match? That's match on the E match. Match E. That apparently those are not what the errors are, so that's kind of fun. No, like actually fill the missing arms. Invalid format error, bus write error. Okay, so let's do like the just error, unknown display error. Right is okay. No, don't stop putting E. This seems like a horrendous waste of space, but the whole idea of the, is it D, whatever the crate's called, DM, thank you. Well, we go here. This crate, DEFMT, is about like, instead of putting these strings in the binary, it just says like look up what this string is and then sends the ID of the string that stays on the computer. Like it's not actually loaded onto the flash. Is ambiguous. Yeah, but Okay, but I'm like, why is it not liking initializing it? So you want to tell me that it's probably that, right. And then, so you match that, and then you go, what stuff? You match that. And then we do this. And what we really should have done is, like, oh God, no, stop trying to insert something. How do I get you to go away? Reject. Okay, so really we should then panic. So get to here and then panic. Fail to initialize is display. And then we go, why are you? Because the trait. Oh no, I can't. Stop trying to stick E on everything, you dumb AI. Unknown error. And then you're saying this is ambiguous because we are going to go up here somewhere and be all like, use the panic. If I ever type panic, use that panic. Okay, cool. So you do this, you call bus, which is okay, regular reference to a reference, which is fine. I am not including the type name because that is horrendous. And then we go, okay. Capitalized acronym. Okay, so why did it suggest the fix and then not apply the fix? Okay, whatever. Okay, and so we go here and we go, okay, what are you complaining about? Because you're saying that STI is... Okay. What do you mean private type alias? Did you make it? No, you didn't make it private, so I don't know what you're on about. Okay. Right. Well, we never use it, apparently. So... Oh no, we use it here. Okay. Wait, we don't use this. So we don't use it. Okay. Simply get rid of this. Just go SPI bus. Okay. Oh, we do use it here. Wait, do I need to? I don't. The I... which is this one. Yeah, same. You, okay. Why are you not working? Okay, cool. Is this sort of quick fix? Cannot. I don't like that it's a yellow line, but I also like cannot. That is horrendous. Okay, no, don't do that. Can we ignore it? Something like this. Let me see, click Clippy. What did it say? Include something about Clippy ignore. Ignore. Allow. Something like that. No, it doesn't seem to like that. There we go. Okay. Don't mind all the yellow lines up here. And, okay, so we don't need this because we're not using a second core. We don't need this because this is all stuff related to the first person stuff. And then plug in. Okay. Oh, that should reduce a little bit of stuff. I don't know why you've got a yellow line. There's literally nothing in there. Why are you complaining? Because it's SPI now. Okay, and then driver is never read. Okay. So what we need to do now is work out exactly how we write something to the screen. Well, actually, I probably should plug the whole thing in. Especially because I've actually assigned pins to everything now, which means I need to like... Okay, so we have our busy... Now, annoyingly, these are all female connectors, and I've got a breadboard, which means they're all male connectors on my desk, which is hilariously meaning I'm going to have to use jumpers between everything, which is just like a complete waste of like cables, but it also like introduces a lot more power waste because like shoddy connections, but you know. Okay, so we're gonna say, sure, let's plug you into yellow, and then we have to plug the green into the green, whatever the green happens to be. This is probably a riveting video of me not actually doing anything because I'm doing something in the real world and have no display for people to see what I'm doing. Okay, so so brown, red, brown, different red. Okay, so plug you in like that. Okay, and then power. Yes, these two. I think. Okay. So red and brown. So it reckons I could give it 5 volts. Should I give it 5 volts? Probably not. Okay, so my busy signal. Busy. And busy is, what pin is busy? Busy is pin 11. And we go to our diagram over here. We'll put something on screen so you guys can see at least something more than just silence. Silence, nothingness. Okay, so busy, pin 11. Pin 11 is 2, 4, 6 from the bottom. Do I rely on this to 4? I'm going to plug it into the one that says 15 on my breadboard, because that's where it says it'll be. Pin 11. Okay. So next pin is a reset. Okay, reset's orange. Reset is pin 10, which is one up from 11. Okay, reset. And then next pin is that one, which is the DC. Okay, so DC is 9, which is skip 1 and go in there. Okay, okay. I hope this is all going to work. These wires are looking a bit dodgy. I'm curious if I can send something to my phone from my phone so you can all see how horrible this is. So next up is blue and blue, which blue is chip select, I think. And DC chip select. Okay, so chip select is, I got no goddamn idea. Where the hell do I pass chip select in? Not here, that's for sure. No, here. Okay, chip select. Where do we pass chip select in? Somewhere. Chip select, chip select, chip select. Display. One of these, not 13. Okay, so 13 is chip select, which is, so if we go off our 15 is, so 13 is 1, 2 below, like that. And then after that we have the, what color was chip select? Blue. So after the blue with the green, and the green is clock. Okay, so green is clock, and clock is 14. So that one. And then yellow is data, which is TX. So that one. And then well, that's terrifying. Okay, so our brown is definitely connected there. Okay, so I plug that into ground, and then I have to terrifyingly plug this into the 3.3 volt line, which I am so worried to do because this is how you accidentally blow shit up. 2, 4, 5 down, 2, 4, 5 down, 2, 5 down. It's so terrifying. 510. Has it done anything? Well, the answer is no, but it probably shouldn't have done anything because. Okay. I'm gonna grab a photo of this on my phone and then like upload it to my computer so you can see how horrible what I've just done is. Because you know why not? Yeah. Camera. And then we go. Let's do this. Let's take a picture of that, and then we go. How the hell am I going to send this to my computer? Because the only cable that I can plug it in with is currently powering the Pico. Can you send yourself messages on Discord? That would be interesting. Maybe. Yeah, I don't think that's gonna work. So how do I send myself a picture? I can do it in Facebook maybe. I only risk Facebook because I'm gonna risk fucking on my own Facebook. I don't think any of this is on screen, so we should be fine. Cool. And then we go. Can I send a message to myself? Wait, no. Go to Messenger and do it. That would be smarter. Facebook's going, I want permission to access your files. I'm like, oh, you should already have permission to access my files. That's because the Facebook app wants permission. And then we just go like, can I don't forward it, download it. Download. Then we close Facebook and we hope that nothing can like leak across. I don't think it should be able to. Okay, and then we go wherever that went. We go here. Okay, yep. We go, look at this horrendous like. They'll just join together and it's yeah. Not really the most you know, a bit of a cancer setup, but anyway, let's work out if we can like clear the screen maybe. I don't know. If I cargo check, is it going to work now? That's the more important question. It worked. Okay, it generated 9 warnings, but it worked. Okay, so we probably want to do something along the lines of clear, which then takes, I guess, mute self. Maybe I don't know. And then you're just going to return, I guess, a result. Just returns nothing and a display error, and we should really just replace with a use. Yeah, cool. Mostly because I feel like I'm going to use it everywhere, and then we're going to go, hey, if I say like self.driver. So we init, okay, which is almost certainly something we should be doing here. Driver.init with a mutable reference to MVC time delay. Okay. So you need to be mutable. So what doesn't it do? Initializes the controller. What do you actually do? I like want it code wise. So you call interface.reset, interface command S. What is SW reset? Wait until idle, delay. Okay, wait until driver isn't busy anymore. Okay. Self.interface command with data device. Command device control. Driver control. high. But it's not 250, which concerns me because that implies that this is not. Okay. So you send data, height -1, so it's 249. Okay. 0, 0. Okay. And then we say self interface command data empty entry mode. Okay. Okay. And then flags entry index. Okay. Okay. So command data board waveform control. Okay. Okay. I'm going to assume that you just. Where are you pulling this height from? Create height width 120. Yeah, so this is just like the wrong height and width, which is terrifying to me because like, okay, well, it's smaller than the actual display, so that should in theory be fine. So we call init, and I don't know, maybe we should look at the examples. So we're gonna go, oh, do not knock over the, okay, so SSD was it 1680. And then we go, hello, can we look at your example? I want to go to your repository and, examples. Now you only have it for the SP, but the SP shouldn't really be any different in like an actual like practical application of using it. So what do you do? So ETS and then clock, and then we set the pins, and so we say, okay, so we this is all setting up SPI, and then the chip select, and then SPI, and then we know. Okay, so we call new. So do I not have to do that? Because driver.init is a thing, but they don't call it. Clear frame on the display. Okay, so they call new, doesn't, okay, so they do this, then they call init with delay. Okay, so I don't need to call init because they've called init, which is confusing. That why have I got access to init if you call init? Okay, anyway. So if I say clear, what I apparently want to do is go self.clear, no, self.driver.clear black white frame and self.driver.clear red frame. This is going to be terrifying because now my display won't say anything. Do these return a result? They do. Okay, so then we got question mark and we got question mark. There we go. Okay, and then you return okay. Well, I guess you just return that one. So clear black and white, clear that one. Okay. 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 So 2 in 13. I don't know what this create buffer for black and white display 2 in 13 BW is. Draw, rotate, and rulers. Okay, what the hell is this draw, rotation, and rulers? I'm assuming this is like a debug thing, and then we're going to say this set rotation 0. Okay, and then rectangle new point 60 size. Okay, so primitive style with fill black. Okay, draw black white BW. Okay, okay, and then say update black and white frame display dot buffer. Okay, okay, unwrap, and then draw red color. Okay. Okay, here's the rotation and rules. Okay, display set rotation, draw, display, rotation 0, and then set rotation, display, rotation 90. Okay, that's interesting. So, draw, okay. Okay, so I'm just gonna like copy all of this. Maybe not the main. Cool, and then we're gonna go into display. Oh, we're already in display. We're gonna go here. We're gonna, hey, can you can you like import that and import this as well? So did you not import those? You did. Okay. So this here also needs to have a buffer, right? Which is going to be a display 2 in. I don't know what does it mean by 2 in 13. Now, I have interesting questions about you. Buffer len. Right, okay. So I'm gonna have to make my own to make it fill the whole screen, but that should be fine. So we need to say that buffer equal display dot. What do they do? They're called something like oh wait, what? No. This is like display 203 BW buffer. Okay. Oh, well, it's got buffer now. Set rotation. Okay, so you're saying that this doesn't exist. So first off, I want to make this actually like an associated function. So like this, and then it's going to take in a mutable reference to self, and then it's going to be self dot buffer dot set rotation, and then it's self dot buffer dot set like that, and then it's again it's self dot buffer dot set rotation, and then again it's self dot buffer dot set rotation, and then you're passing in display, which is good. Okay, so set rotation, apparently you don't have that in scope, which is but we just need to bring in the prelude. That would probably help. Where did you put your prelude? Here. No. Yeah. So I'm bringing like everything in from the prelude. So let's just bring the whole prelude in, you know. That will probably fix half the fucking issues as well. So then we're going to say draw text. Did that come in with the prelude? Okay. So then it's self.buffer all the time. Except we need to again move ruler up into being an associated function. This is going to take self. It's just going to be mutable self, and then you would just say self dot draw ruler. Yep. Cool. You're the same, and then you could, okay. This is like amazing. They updated Copilot, and now it's like it pops up this thing. It's like, yeah, do you want to change this inline stuff? Because it was the biggest thing that was annoying me was the fact that it set rotation. What are you saying? But it's in prelude, and I brought prelude in as a glob import, didn't I? Did I not? Yeah, no, I brought prelude in as a glob import, so I don't know what your problem is. Okay. Well, we'll fix that in a second. So lines coming from somewhere. Embedded graphics primitives line. Did they do that in this one? I'm assuming they did it in this one. Black, red, embedded graphics. Yep. Okay. So we have to import line and void, pointer, and we need to import the color. That's not what you with stroke. I'm assuming that they brought in black, which is their black. So we have to go to here. We have to go color black. And they also brought in the color red. Well, we're not using red. Now, are you just a number? You're just 0. Okay. Off. Right. So set rotation is still not working. Into style, we need to bring in this, fine, and it's we need to replace that with self. Yep. And then same here, we need to replace that with self dot buffer. Okay. Draw text to string column as I32 label. Okay. Cannot find the function So what I need to do is go up here, go up to the top of this thing and go, what did you bring in from embedded graphics? Just bring everything from embedded graphics. There's embedded graphics. Yep, that's it. Let's bring all that stuff in. Font 5x8. Okay, so that's probably going to fix a bunch of this stuff, I would assume, when it catches up. Yeah, oh, I'm using embedded graphic text now. Text style builder. Again, it just takes so long to actually update that I changed anything. Well, you know what the problem is probably that it didn't save it. I don't know why. I keep control-S-ing and it's like not saving. Okay, so why is set rotation not doing anything? Did you... No, so set display, and then display, when you called that, you would... So according to this, set rotation is just a thing. Like, look. It's just a thing that we can call. So is it just spelled wrong? Like, why are you not able to call it? You can call it. I don't know what you're complaining about then. Expect struct union found type display struct. Wait, what? Huh? Okay, the name display is defined multiple times. Oh yes. Don't bring in display then? Was that what? Okay, right. That's what the problem is that I'm defining display and then they're using a type called display. So you need to be renamed to e-paper, like so, e-paper. I think technically it would be like e-paper. Okay. Anyway, you're saying that they're never used, but that's fine. So draw ruler. Okay, so draw rotation and ruler. You bring all that stuff in. I'm gonna have to just like pinch this whole crate and then modify it so that I can specify the length and the width, because for whatever reason they hard coded the sizes with instead of like letting the user define them. That's the all right. This is the example, which is its own crate entirely, which is even more confusing to me. Okay, how much actual code is in this thing? A handful of things in it. Okay. Update. Okay, so if I cargo check this, okay, and then when we go here, we go, hey, when you're done. So what I want to do is I want to have like a FN clear screen, like so, and this is going to take in a display e-paper. Well, why are you importing it as a display e-paper? Why not like actually import display.clear? So we need to import that. All right. Did you just like not update that I call it? No, I'm gonna use it. I just never used it in here. Wait, how did I just not? God knows what I've been doing. All right. Paper no. Okay. So annoyingly, well, this is just even more reason to steal this fucking thing. Derives graphics lib maximum height this driver. Wait, what? Okay, wait, so they're never mind, I don't need to modify their crate because their width is 276, which is wait, no, I do, because they're okay, they have a max width and a max height, which is correct, but they have a like an actual width and height, so I may have to go and edit their stuff, or like make my own copy. What I want to do is track down where the hell this type is, this display error, and I need to like find it and then derive it. Okay, so you use it, and then you're using it, and you're here, and we go, hey, can I just like copy this wholesale? Wait, config attribute feature 0. They have it. it's just not a feature that I can enable apparently. Wait, is it just a thing you can do? Can you just like enable a dependent crate on the other on another crate? That's kind of cool if you can. According to their crates.io, they don't have a feature called DFMT, but it appears that because they have the crate as an optional, you can turn it on. Is that how they've done that? Features, graphics, embedded graphics. Wait, how exactly are you doing this witchcraft? Because it worked. Like, has it worked, or is it just not? No, it's just not compiling now. I assume when I call check, it's going to just go away. Yeah, you can make mobile games with Bevy. Sorry, I missed your message. I don't know how long ago you sent that. But yeah, Bevy supports compiling to iOS and Android. From what I've been told, Android is really buggy, and iOS is like somewhat feature complete. I don't actually know at what level you can develop a game, sort of thing, but interesting. No, so yeah, like you can, but I've never actually done it, so I can't like advocate for how well it would work, but is definitely a thing that can be done. Now, what do you mean by you can the fuck kind of? So that's some kind of conditional. So in display, they have a config attribute featured, but you don't have display interface crate display. The display interface is the actual crate that's caring about this. So that means that display interface is actually what I need to turn the feature on, and then what actually importing display interface is probably embedded display, which makes me go like, if I go to embedded display, haven't I got this turned on? Toml embedded display. So can I force embedded display? Embedded display. That's what it's called. I'm not going insane. Oh, that's embassy plugin. You go here. Embedded interface. I was going insane. So close. Oh god, what have I done? And how do I make it go away? Anyway, and so it's embedded interface. So we go back to our tool here. It's not embedded display. It's embedded interface, and this equals version is 0.5, and feature equals. Okay. Now, why are you yelling at me? Because that's not how it's spelled. INTER, and FACE, FACE. Why are you not? It's because it's called display. Display. Display interface with that feature enabled, and then that's actually working, which means that we go like check. Are you going to tell me that it works now? No. Can't borrow display as middle. Of course not. But that's a completely different error. Okay, so there's clear screen working, and then if we go up here and we say, hey, can we like add _ startup systems, and then startup. Oh, wait. Never mind, I got that right. I for a second there went all the way back to like Bevy 0.10 where I was like, add startup systems, but like it's been that in ages. But AI got me and put systems anyway. Startup, clear screen. Okay, so I am curious because my runner here does not run startup, but I don't know if normal Bevy does. Like, is this something that I actually have to make sure I run the startup system? Can I like, I need to like print that it ran this, kind of like
log or info, yeah, info. Clearing display. Thank you. Because I have there's a sneaking suspicion that it's not actually going to run that, because my runner never runs the startup. But maybe I'm just wrong. Maybe when you call update, that's when it does it. Like, what do we do? We call app finish cleanup. This is just I copied this from what Bevy does. Then we say spawn app run, and then the app run just calls app.update. Is this one? Is building plugins? No. Then we say sub app.update, and then we go, hey, is span label world clear trackers? We call extend run default schedule. Okay, and trace, and then it's a run default schedule. Label extraction sub app into sub app update. So this is for each sub app. So we run default, and then we use his building plug. Okay, and then we say world.run schedule label, and then we passed in something, didn't we? Update, sub app update. We said run default schedule. Okay, run default schedule, and then we pass in update schedule. Self.update. Okay, so we pass in the labels. So I don't know what the update, how that's set. Maybe so this is a sub app, and then plugin state update schedule none. So something at some point sets this to some. Yeah, see, it never called clearing screen. So I don't actually have any idea. To be honest, I'm amazed that it even was. Interestingly, the LED is not blinking anymore, which means that I have broken something. So why is toggle LED not working? Can I get you to info toggle LED? Is toggle LED running? Have I just broken? Are we even getting to toggling LED? We've got a panic here. Bevy should not return from run. Okay, so maybe we just never sent it to no. What? Yeah, why is it not toggling? Did I slow it down too much? Or no, because I'm getting to a point. Okay, so it's just never running update, which interestingly I think means that, like, maybe when we add a system, if it doesn't already have a system, it's setting it to update. That, or it's just never getting to here. So it's saying something about free. Now, I don't remember where I got it to print that, because it's something like, again, it sort of came with the legacy of the other person's code that I was copying. So somewhere they print free. Ah, right. So that's when we start app, which is the hilarious thing. I was just wondering why it was so high. So when we get to run, I want to get to run. I want to say run, and then you do all this, and then we want to say print line free, and then heat.free. You know, see how much memory, like, actually loading Bevy takes up. Because I was looking at it and going, like, it's only taking up not even 100 bytes. Okay, so it's not getting to update anymore, which is fun because it means it's getting stuck somewhere. Now we get the fun joy of being like, how the fuck do I track this down? So free app LED. So okay. So let's just go with info. A couple of info. Bus initialized, and then we're going to get to here. We're going to go display initialized, and then we go. Where are we getting stuck? Insert resource display. They're getting stuck somewhere. I'm no longer initializing, clearing the screen. So where the fuck are you getting stuck? Probably trying to initialize this with the goddamn mutex, and then because the mutex is a thread mutex, it's probably getting stuck somewhere and not being able to initialize the mutex. Ugh, this is embedded programming for you. The beauty of it with Bevy is that once the Bevy app's running, Bevy takes care of the rest. So, first off, apparently I made it worse. Because now it just says free. It didn't, which is more confusing because it should say starting Bevy on core 0, but it didn't, which implies that it's... Oh, this was working, right? Like, can we say like info? Sure. Are we getting back from here? I mean, we have to be, because we're getting to this free. I'm assuming it's that free that's printing. I'm just surprised it didn't print starting Bevy on core 0. I also think that this should all be up here. Like, it should be in main. It's split into its own app because, again, I modified someone else's working code to get to this point. So it's a little bit like laid out like they were doing it, but I've just kind of modified it to get to do what I want it to do. So where the hell are we getting stuck? Because starting Bevy on core 0 is like never printed, which is weird because surely it's waiting for the... Maybe it's not. Maybe... Okay. So first off, that's 15 megahertz, which means that hilariously, apparently 12 is maybe I just never ran it. What do we go for 20 maybe? Like, is this a number that we can specify? It was definitely working at 30. So it got to here, but it just never got to here. But is that because it's not printing it, or is that because it's not getting there? I mean, the other option is that we're like running it so too slow, and like it's legitimately taking that long to initialize. No, there's no way it's... It was working. Oh god, I never fucking saved it. God, no. Okay, one option is that I'm messing something. Oh, it didn't like that. Wait, could not... Well, that was interesting. So the options really boil down to, I've plugged in the display, so the display might be doing something. Okay, now I can't even write to it at all, so that's fun. What have I done? Well, I give that a concerning level of wires may have touched that are like just like active. Like 5-volt may have just touched fucking. So I may have cooked my Pico probe, but well, no, let's talk it. So I was probably cooking my Pico probe. The 5-volt and the ground are not very well separated from each other, and they had super hot glue on them, like to keep them so they couldn't touch. But that's come off, and they probably touched, but not enough to kill the chip. Probably not good for my computer, shorting them to ground. But anyway, SPI bus initialized, but the display never initialized. Now, did we get a display error? Have we got to here and have we panicked? Who knows? So we go ebus new, and we go hello. Well, right. So we say something like info. Driver initialized, and then we say buffer initialized, and we go, which one of you is having an issue? So, because we definitely got to SPI bus initialized, which means that the
only place we can get stuck is between here and here. That's also assuming that it's actually printing out the text properly, because that is another possibility. So something's okay, that actually makes sense. That probably means that something's wired wrong, or something's not making continuity. Okay, so that actually, because it means it's probably never finishing its initialization. It's like never calling init properly. So now we have to pop our multimeter out, connect our wires together. So it's not going to like that, because I just literally unplug the power to the thing, because I need to be able to get my probe, which is... So I should be able to use my multimeter now. So if we rerun that and actually get it to send the code, I can now use my multimeter again, because it was connected, like, so that I could measure the amps, but obviously I can't measure the amps to stop running. So let's measure voltage, and let's work out, first off, have I just like not plugged the display into power? That would be the, like, my most likely guess is that the voltage between here and here is not 3 volts. Will it help if I plug in the voltage mode? Oh no. Oh no. The chip is not responding. Oh no. Please do not cook yourself. Oops. Did I just hit reset on something? Hey, it's working. Alright, anyway. Again, do not knock soft drink all over your desk, or like energy drink, which is even worse. So between here and I think it's this one is ground. Okay, 3.3. So you are getting 3.3 volts to your red wire, which is your VCC. And then the ground, wherever the ground is going, okay. Question. Between you and you, is there 3 volts? No, if I had it the right way around. So there is 3 volts between you and you. There is 3.3 volts. So it's definitely getting power. Again, it didn't like whatever I did. I apparently reset it, which is not a good sign. Is it panicking? Like, maybe I should be reading what it's actually saying it happened. So it's saying it couldn't clear something, could not clear all hardware breakpoints, an ARM specific error occurred. That's concerning. Because it's writing to it, but it's then failing to execute. No. Bus, okay, so SPI bus initialize, which means it's getting stuck here. So it's saying the driver is never initialized. So we should probably put an info here and say info initializing display. And then we go, okay, so what the hell is your problem? My assumption is that you're never getting this. Well, it means that the issue's in here. So busy is pin 11. So we'll pop this back open. We're gonna well, one of these is the right thing. Yeah. Okay. Pin 11. Pin 11 is busy. So your busy is purple. So I should probably just connect power, which means you're not going to like that because I just connected power. Anyway, I need to be able to probe shit without worrying about accidentally blowing something up. So busy. We'll put you into continuity mode and we go, okay. So first off, busy is purple, purple is orange, orange is that one. So first off, are you making it all the way to the chip? I want to say it's that orange because it's 15. Okay, so we need this to be somewhere I can read it. Nope. Please do this. Okay, so busy 11. 11 is 15. So the one labeled 15. So if you are 20, 19, 18, 17, 16, 15, that one. Okay, so next is DC. So DC is 9. So 9 is, so going from you, so it's 11, 10, ground 9. Ah. Well, that's interesting. You're getting connection here then? Well, that's white, so that would definitely not. No, reset. So wrong chip. That would explain it. Reset's 10, so 10 is one above 11. So that would be that one. Okay, so then you would be BP. Okay, then chip select. So chip select is blue, and then chip select goes where? Okay, so chip select. What have we got for chip select? I want to say that chip select is 13 because that's what it's got. But that's not actually anything. That's just like an example. I don't think you actually have to use any of those. You just use literally any pen. So something tells me that it's like you can hardware accelerate user, I think. God, I got too many things. Okay, so when I pass in here, I pass in chip select somewhere. So chip select here is an output new high 13. Now the other issue is I could be putting those pins in the wrong mode, but anyway. So chip select is 13, and the 13 is 4 from the bottom. So chip select being 4 down, and then 1, 2, 3, 4 from the bottom. Okay, so chip select is working. So clock SCL, which is 4 from the bottom. And that one, okay. And then so SCL is 14. Is 2 from the bottom. Okay. And then SDA, which is the bottom one. Okay. And then obviously ground is ground, right? So I just select U. Okay, and then VCC is 3 volts. Alright, so every pin's connected correctly, which implies that what? Okay, maybe we should look at what it does when we initialize it. So we initialize you with SPI as high, which I assume is correct, but I don't actually know. Maybe we need to initialize commands in the other state. I would have assumed that when I call new so we pass in display, and we say bus output new, we pass in busy as 11. Okay, and then they have to be correct because I've specifically told this that it has to take in a busy's reset and DC, which it doesn't like that DC's that way. But anyway, can I just F2U to DC so that like the IntelliSense sees you correctly? Anyway, so we then get to here and we initialize our display. So I'm assuming we're getting into this system because otherwise that'd be weird. So we get to here, and so busy is an input pin, which I assume is correct because you state that it needs to be a busy as an input, DC and reset are outputs. So maybe you're supposed to be low, or maybe reset's supposed to be not whatever it is, so it's getting held in the wrong state. But when I call new, what do? You say display interface new. So then you immediately pass all the pins to the display interface. Okay, so we go to display interface and we go, okay, so display interface just passes the pins in, which annoyingly means that there's a not insignificant chance that unless init does it, interface reset, reset set low, delay, reset set high. Okay, delay. So it definitely will set the reset pin to the correct state. So it sets it low, sets it high. Then we say command, and so the command will say DC set low. Okay.
Alex, 5 minutes to food.
And it says SPM. So why are you not? It's possible that this isn't working. Okay. So it could also just be that the chip's fucked. And that's always a possibility. Like, how do I know if it's working? So wait, when you call init, did you never pull? You pull the reset pin and then you pull the command pin. You never pull the chip select pin. But is that because... Well, here's when you do write, and then just take a screenshot, I guess. Going. Write, and then write calls transaction, and then transaction is implement it yourself. Okay. So I'm assuming transactions when it pulls it low, so maybe I should not, maybe I should initialize chip select low. That doesn't make any sense. Where, I need to know, where is it actually getting stuck? I'm assuming just it's waiting for a response that it's never getting. Now, I could look up the oscilloscope and have a look at what's actually happening on the channel lines, but like SDA. Because you want an unless I've hooked that up. So I said TX only. I'm assuming TX is out. I may be wrong. So where's our SPI bus? When do we initialize you? You're in main. Let me say here, we have new. Let me say, okay, new TX only. To block. Support writes only. Supporting writes only. Okay. M out, S in. Okay. The TX only, and that means we've definitely put the right pins because TX. And then you obviously don't read anything back, so A. Yep. My normal mistake I make with this is I always got the clock and the thing backwards. But like I'm 90% sure I checked this. I went, your TX is 15, and I'm currently touching A. Yep. And then if we touch clock, clock's not. Yeah, the clock is the next pin up. And we go, no, that's interesting. No, clock's definitely working. The other option is to swap to a different display that I have. The issue with swapping to a different display, I'll either have to rewrite the code to use the new display in its driver. That could be the issue, actually, is that because we've got the clock turned so goddamn low, it may not actually be able to communicate at the speed that we're telling it to communicate at, and therefore it's probably just dropping a bunch of bits. So let's turn the clock right back up to, like, let's just comment this out and say let the config equals this, so 25,000, and then maybe don't tweak the voltage either. Because, okay, wait, what? You don't like this because mismatch type? Yep, no, we just want to default. Just default. Now, this is going to use a lot more power, like orders of magnitude more power, but if it means that the screen works, then we can like dial it down, because I assume we just need to tweak the SPI to not use such a high frequency when we literally don't have a clock running fast enough to write it. Okay, so it didn't like that because, oh, yeah, it would definitely help if I, like, plugged it back in. It helps if you plug things in. Okay, quick right to it. So, go back up to a nice high clock speed so that we can actually... Because I'm assuming that when we pass in the SPI bus, we never configured it to do anything but. So, depressingly, still not doing anything. This is not fun. Where are you getting stuck? Now, my assumption is that, like, you should be returning an error if something goes wrong in the initialize. Like, when we say new, and then we say new, like, surely you call init and then call that, and then, but like each, in your init, you call reset, you call command, and then command passes up an error. So I'm assuming that if something goes wrong, you bubble up an error, right? But you're not bubbling up an error. Wait until idle. Okay, so wait until idle. So I'm assuming, did it state?
So top one's busy. So if I say busy and I don't want to touch there. Idiot. Oops, that's continuity. Well, apparently busy's connected to ground at the moment, so that's fine. Out of curiosity, is busy connected to ground normally? I'll make you voltage, thank you. -3 volts. Oh, that's probably why. Okay, the busy is high at the moment, which makes me think we're stuck here. Wait until busy. Wait until idle. So that's wait until device isn't busy anymore. Busy equals high. Okay, so annoyingly, I don't think I can modify this code. And yes, so reset. So reset just pulls it low, pulls it high. So maybe we should look what command. So interface, display interface. The fuck is a display interface though? SPI busy display or reset. Okay, and then you're just exactly that. And then say command. Is it inside this? Okay. Basic function for sending commands. Okay, so you set that low. DC error. So it's apparently not having an issue setting that low, which I think is fine because like it's an infallible thing in the Pico. Then we transfer the command, and this is done by writing command. So in this particular case, we're just writing bus write. So where are we getting stuck? Because it's literally high at the moment, which implies that we're either getting stuck before it calls. We're either getting stuck here, which makes no sense because what do you delay for 10 milliseconds? Again, delay for 10 milliseconds, so at most 20 milliseconds before it gets to there. Then we say command, and we say, so command does this, which is, this is infallible, right? If I remember, like it's literally infallible because we're using a Raspberry Pi, and then transfer the command over SPI, which is when you to write, and then I'm assuming you have a timeout. Do you have a timeout? Or you just say bus write error? Okay, but like, what are the errors? I'm assuming it's timeout. So like, I don't think we're getting. I think we're getting past here, and we're saying like you're idle. The only thing, like, we only just like connect to the oscilloscope and like try and probe what the hell's happening.
Yeah.
And so command with data, and then so we say driver control. Okay, and then we set the height. So this could be the issue, is that we're setting the height to 250, which this thing is bigger than that. So it's possible that it's not liking that, but then again, it should be returning an error. Like, it should be returning an error, Use full frame. This could be problematic. Get RAM area. Choose full frame / RAM. So this could be in set RAM counter. Start from the beginning. Okay, that's again not like my issue is it's not getting to here, and so it could be the embassy time delay is not working properly. But we've gone back to default and everything, so that doesn't make sense. So, and then all this just literally constructing stuff. So this can't really fail. So it can only be failing inside init, and the only thing is wait until idle done. Oh wait. Busy equals high. Okay, so it is set to high. So this chip is saying that it's busy. That's what I can conclude. Is at the moment it is set high. Is it? Apparently not. Wait. Wait a sec. Did it just take that long to initialize? The display didn't do anything once initialized, but that's because I haven't called. I removed the thing. Wait, does it just take that long to initialize, or did I accidentally fuck it and like touch two pins together? And because it's possible that I shorted the reset pin. Hello, Richard. So
It's possible that I shorted the reset pin, which then reset the display, which then meant that it sent this signal and it kept going, which is annoying because it would imply that like it's getting stuck. So it's initializing the display, and then so if I poke here and here, it's busy. Okay, so maybe it's not setting the reset properly, because it said something. Well, the thing is maybe if I just wait, maybe it's just a timing thing. So reset is pull low. So if I pull, one thing I could do is pull the screen. Is just pull it low so that the chip moves on. But what I found interesting about that is that when I pulled it low, like whatever I did to get it working, which may have just been waiting, may have just been that it literally takes that long, which would be terrifying because that implies that this e-paper is real slow. But what could have happened is that it's getting stuck waiting for it to not be busy, but it's then just in a busy loop or something. No, it's so I'm assuming I pulled the reset, and then once I pulled the reset, something went wrong. So reset should be high, right? Because that's what you do. When we go renew, when we go init, I think init calls reset, and reset pulls it low, then pulls it high. So that implies that if I touch reset and ground, it should be reading. Oh, it's not though. Wait a second. What? So busy's reading, but reset's not. Okay, question. Reset. Which one's reset? That one. Okay, so reset. That's very bizarre. Wait a second. Okay, wait. First off, is that correct? Reset. Which pin's reset? Reset is the orange wire attached to the orange wire, which means reset should technically be. Make sure I've got this correct. Okay, so looking at the physical way I've got things set up, reset is plugged into 14. So we go up to, we go here, we go, reset is 14, yes? No, wait, no, pin 14, which is 10. Well, physical pin 14, which is 10. Okay, yeah, so reset, that reset, that reset. So if I do that, it says no voltage between you, and then the voltage between you and ground is nothing. Interesting. The chip is currently set to reset. Okay, so let's unplug the device, which is going to then cause my Pico to not like that. And then we're going to go, hey, why are you... So you have continuity. If I send you to continuity mode, I'm going to have to end the stream soon because I've got to eat, but I want to get this working. So, okay, so there's continuity between reset, which means that for whatever reason... and reset's not touching ground, which actually kind of makes sense. Okay, so reset is connected to the reset pin. So something is causing reset to be low. Am I starting reset low? No, I'm starting reset high. So that's interesting. I start reset high. It pulls reset low and then never pulls it high again. If I measure voltage between here and freaking ground, when I plug this back in, apparently there's a, that's a bit weird. There's a negative 2 volt bias, but anyway. Reset and ground got pulled to 0. Did it ever go high? Why is Why is that happening? Let's try a different pin maybe. Maybe that pin's fried. So let's change reset to... Hello, Poisander. So reset. So reset's 10. Let's go, like, what is another physical pin nearby that I can just plug that into and see? Maybe I've fried that pin at some point. So I got it working at one point, so that's interesting. So we're at 10 and we want to go to maybe 8. So let's go 8. Pin 8, okay. And then it's going to complain because obviously it's not wired properly. And then we're going to go pop you over to here, which puts you in physical position 11 on the board. And let's go, as is position 11, 8. Yes, position 11 is 8. And we want to go check our continuity between reset and pin 8. Okay, so reset 8. So now if we go back to our main and set 8, maybe. I can't imagine though. So we set the chiplet tie. So that's interesting. Now when do I pass you to 10? We want to pass 8. Oh, not asterisk 8. Okay. Oh, it doesn't like that because it expects a pin 10, which means I just never saved here, did I? Okay. So 8, and then everything should be working, which means that when we flash this, if this just works, that implies that there's something wrong with the reset pin. Yeah, I don't get it. Maybe I have to pass it in low. It doesn't state that though. And the fact that like first thing it does is anything like that. Oh, I unplugged it back in. That's fine. It only goes high. But no, yeah, it should only go low for 10 minutes. Okay, wait. Did I run check? I did run. Okay, so So why are you not working? Okay, so we've got to initialize, and then okay. So I said, what is the potential between ground and reset? Oh, well, apparently the continuity is there, which implies that they must be the same voltage. No, it doesn't, because it will tell me there's continuity if there's any voltage. Okay, well, they do have continuity. If I go, okay, so that means that the pi is actually pulling them to ground because there's continuity. There's no continuity. Like it's not the default states that they're connected. So it is in fact pulling it low. But why is it pulling it low when it should then be pulling it back high? Why is it leaving it low? Does it need more power? I feel like I'll fry the Pico if I put two, like just short between. My thought is I can short between okay, what if I pass reset low? See, because you say new and then you say so new and then initial state and then set initial state. So you set low and then set as output. Okay, so that's interesting. That's well, that would fucking help, wouldn't it? I just found the issue. It's that DC was in reset and reset was in DC. So if it just fucking works now, I'm real annoyed, but it's probably just going to work now because, you know, like that was a quite clear bug that was happening. Okay. And then we should just like run everything and plug in the line anyway. Oh, okay, didn't like that apparently. No, well, no. Oh, right. Duh. Plug it back in. Right. Also, I wonder if I'll get slightly better efficiency if I skip the diode. It's supposed to also help. I don't actually know though. I think like if we go to the piano. Okay, so here. we just, oh, it's blinking, which means it made it. Okay, so I was just an idiot and plugged them in fucking backwards. Okay, of course I did. Anyway, there's VBus and VSys, and I don't remember which one's which, but like one of them has a diode connecting it to the rectifier, whereas the other one connects directly to the rectifier, which means that if you plug into one or the other, you get better efficiency. So we'll work that out later when we get to that point. Anyway, we need to call clear on our screen now. So I am curious if it will work with the lower speeds and the lower voltages. That drop back down to 10 and go. Okay, first up, stop printing so much shit in the console. I gotta, like, all the initializing stuff can stay, but like, we also want to turn wherever it was the, when do we add the, yeah, clear screen. Now, this is going to be fun because this is going to clear my, my ruler, and then we want to go, like fn draw, rule. Rotations and rules, which is going to take in a resume e-paper display, and then it's going to call update full frame apparently. No, okay. So we say draw, and then I guess, is that public? Yeah, it's. I'm going to say apply, maybe? I don't know. I have to go back to their example and go like, self while we wait for all this stuff. Like the result. Sure. Oh, clearing the display. Nothing's happening. I don't think I applied it. Display. No, yeah, this is got a display error. Yeah, okay. Okay, so, draw, clear. Okay, so we clear those, but I don't think we apply them, maybe? So clear, no, driver.clear frame. So, why did that not work? What am I not doing correctly? I want to go back to the actual crate on here and go, well, nope, that's the display. We want to go to your repository and then your examples, and we just want to look at what the example did differently. I'm assuming at some point it calls something that then causes it to, like, push the clear. So it clears and it unwraps, which is interesting. It's possible that the issue is that I'm not unwrapping them, but I doubt it because unwrap. No, I'm just returning them, so that's fine. When we call clear, we then, yeah, we put the error. So did it, so we call clear display and we're now blinking, which means clear display didn't throw an error. And this calls clear. This clear that. And then we initialize a new, and then we draw rules, and then we say set rotation 0, rectangle, this, init stylized, draw. Okay, so that calls draw. Do you call draw? I think you call draw, don't you? So my assumption is that I need to somehow apply the buffer at some point. I don't know. So you said draw rule. So you say draw text and you pass in the buffer. Yeah. So my assumption is that you have to send that sometime. So update black white frame. Yeah. So I never call that. So when we call update, we're going to say self dot driver dot update black and white frame with self dot buffer dot buffer. Now update the whole black and white buffer on the display. Okay, so then we want to go here and we want to go we want to call draw rule, and then we want to clear, and then we want to call if let error equals display no dot update. Okay, did I leave that private? Is that what's happened? Probably. Okay, and then we say display dot update. Can you actually we can tidy that one up here because we can actually just display the error. We can just panic the error now because we worked out how to turn on the error printing. So what was it? So display and apply. No, it's public. We just maybe never saved the file. Why can I not call update on this because e-paper in the current scope? No. Oh, did I not put it high enough? No, it's ePaper has a function apply, which is called on self. Excuse me. Oh, it's called apply. That's why. Okay, so in theory, I don't get this because we call clear, and clear says clear the black white frame, and it says self dot use full frame question mark. Okay, and then to do allow non-white background. Okay, white dot get white value. Okay, so white's a 1. Okay, and then self dot interface command write black white data. Okay, and then interface data x times color, and then what? Okay, clear red frame. Okay, so well, it doesn't like that, but that's unrelated. So we want to clear screen, and then we want to draw rule rotation, and then we want to go to like dot chain. Like that. Okay. So if I run this now, is it going to actually like work? Who knows? Oh, I've been looking at other stuff on my monitor, so I haven't missed yours. Too slow. Yeah. It is too slow to play actual Tetris. Like ePaper, it has a refresh rate like the one I'm using. It says 3 seconds, but the plan is for this to be an extremely low power environment. Like we're talking like a few milliwatts, sort of like low. Like I won't have the power to run a real-time display. I'm already going to underclock this thing. I'm underclocking the speed down to 10 megahertz. I'm underclocking the voltage to 0.8 to get the like it as low as I can. So the idea isn't to be able to actually play Tetris on ePaper, though in theory you could, because I saw something that said that if you only do partial redraws, it can do them in like 0.3 of a second. So that's it's still only 3 FPS. But like the Tetris, you could do like an actual like a phone level Tetris where you can press button left and right. You could do that if you were just only partially redrawing the screen, and then like every time they place a block, redraw the whole screen to clear the artifacts. But I'm doing something like I need the ePaper's ability to be turned off and still display something. So depressingly, nothing's displaying on my screen. Now I'm going to make sure that this piece of clear plastic isn't actually got something written on it, and therefore I'm like missing something. No, it definitely appears that like the screen is just not updating with the ePaper. Oh, that's annoying. Yeah, so the next person. WGPU and Bevy systems to do. Yeah. I don't know if you were to get the whole Bevy STD, especially because like I want to say the rendering. Like I was thinking about the day, I was going like, oh, it'd be really cool instead of doing Tetris. The reason I picked Tetris is because Tetris will work as like I can math out in my head how I would draw like parts of the frame to be able to make it like update with minimal power. But I was like, oh, it'd be really cool to do Minecraft in the like what I've got planned for this video, which I'm hopefully gonna make this weekend. But like I went, oh shit, but I can't like mentally work out how you would do 3D rendering in an embedded. Like you have to write everything really custom for the specific architecture that you're on. So I don't know if the rendering will ever actually make it. But if you get web GPU, maybe. But like I feel like it may not work as well as like because most embedded environments just are not going to be able to run things like shaders. Well, I would assume. I don't know. I should never considered how low. Anyway, I don't know why my display is not actually updating with anything. Am I just doing something wrong? Anyway, I gotta go eat. So I'm gonna call the stream for now. I'm gonna mess around with it a little bit, and I might start streaming again if I can get this working. But if I can't, I don't think you guys want to watch me fuck around like just changing values and looking. I'll hook up the oscilloscope and do all that stuff off stream and have a look. But so keep an eye out for the stream, like another stream to start in like a few hours if I get it working. Otherwise, I'll probably do something tomorrow. I don't know. It depends how this video idea starts working. Any questions, ask me in Discord. Also, you'll find that linked in the description. Where is my end stream button?